So quickly jumping on as to what we have for the agenda today and how does it all include, right, to the wider agenda of large-scale production engineering. First and foremost, we are starting off with something that everyone in the room has had to deal with at one point of time or another, security, right? Uh, folks would have heard about the XZ vulnerability, yet another supply chain management attack. And how it came to be found is very particular to something that we see on a day-to-day basis, right? We see a packet dropped, we say an increased latency, and we say that, yeah, something is wrong, network is bad. In this case, an engineer dived deeper into it and identified something, hey, this doesn't sound right. And that's how this came to be found, right? So Sachin would be presenting us about what has been his experience, like how was this entire thing found, and he'll walk us through the pieces, right? After that, we have Avikalp, who will be sharing about how to do code reviews in a scalable manner. How do all of machine learning capabilities, or how do even individual pieces come in together? How do IDs help us in these pieces? He'll be talking about it from individual contributors' perspective, how to review PRs and how does it all come in together for us to be faster, and how can we do it at a much more scale level, right? After that, we have self-service with GitOps. So Samit will be talking about it. A whole lot of people have been working around with GitOps, be it in context of GitLab or be it in context of other places. How do we make it self-serve? What are the advantages? And how do digibanks at Grab make use of it to make it easier for our own developers? And how do we enable them to do things on their own, right? So that's something that we'll be talking about. That's the presentation from Grab teams for today. After that, we'll break up for lunch at 1 o'clock. After that, we have OpenTelemetry by Kannan at 2 o'clock. Kannan will be talking about how do we do tracings, how do we enable OpenTelemetry in Kubernetes, and how do we make use of the operators to get the best out of it. And last but not the least is a talk which is going to start shortly around 3 p.m., which is going to get you ready for 3 a.m. logs in the morning, right? All of us definitely look at our logs all the times, and we miss most of the things most of the times, right? How do we get it to a better stage? How do we get it to a scenario where it pinpoints the problems in the fastest possible way and helps us to resolve issues? While we are talking about all of these things, I think something that is there at the top of our mind, if I have to hazard a guess, I'll be very surprised if no one raises their hand on the next question. How many of you have heard about AI? See, this was one question I was very sure everyone would raise their hands on. Something that is missing in this presentation and for the agenda for the day today is how is AI gonna disrupt everything that we are talking about today, right? From the very first question of security and vulnerabilities plugging into supply chain management. And this isn't the first attack that we have seen in recent times, right? Before this, there were SolarWinds. Microsoft was impacted similarly across the board. All of these things, as of now, get caught simply because an engineer is diligent enough to say, hey, something is wrong. Oops, something went wrong, right? How is AI going to come in there? How is it going to plug in there? So far, we have been simply making use of ML to develop our models, but how does AI come into and bring it all in together is something for us to think about, right? Even in context of, let's say, be it GitOps, be it in context of code reviews, how does AI come into play and help into there and all of those things? For us as Grab, I'm still going to talk about me as a Grabber. How is Grab playing around with it? Something that we have announced publicly recently is we are actually working with OpenAI to develop more and more things in there. How can Grab benefit it internally? And when we are talking about internally, it's similar use cases, right? How can we do better code reviews? How can we create better marketing schemes? How can we do better security management? All of those things is something that we should be thinking about it. The way I think about it, AI isn't something that's going to simply replace us engineers to say, hey, our jobs are going to be at risk. AI is what's going to make things like these. How do I do it faster? How do I do it better? Is what is going to make it clear, right? AI hallucination is going to be there for at least a couple of years, right? It's not going to vanish overnight. Essentially, if you ask, and this has again been in the news over the last couple of weeks, one major operator provider saying, hey, is XYZ good during a certain period, and which everyone mostly knows that, yeah, it isn't a great thing to do, and AI answering, yes, definitely go ahead and do it, right? So all of those things need to be sorted. The first time I did something, which is yet another internal app, I mean, it can be accessed, but it has not been configured for other Slack groups as a Slack cleanup, right? If I was there at Graph for about 7 years. Over a period of time, you simply accumulate Slack channels. How do you clean up? How do you do pieces? I had about 1,000 odd Slack channels when I initially started looking at it. It took me, I think, about 3 nights. When I say 3 nights, I wasn't working upon it 3 continuous days, but simply whenever I could figure out time, right? And this was still about a year back, December of last year. I could spin up an entire app. It was a baseline JS app which could list all the Slack channels and do all of the cleanups and pieces, right? So those are the things which helps to make it faster. In a typical world, it would have had been Google plus Stack Overflow of how do I do XYZ. In this scenario, it was simply of, hey, I want to manipulate this JSON, I want to edit this JSON, give me the code snippet. It didn't work out of the box on the first try, but it definitely saved me, I would say, 70% of the time as compared to had it been just a search engine and just a Stack Overflow or something like this, right? So that's the core of it. Looking forward to more of such talks related to it. Grab will be working and investing heavily on it. So if that is something that's of interest to you, do reach out to grab.career, see what roles, what open opportunities are of interest to you, and then, yeah, definitely look it up. Feel free to talk to a bunch of grabbers here. Ankit is here, Anil is here, Aprajita is here, and a whole bunch of grabbers at the back. Reach out to them and then see and assess how does it help, and how can you make use of it on your day-to-day working, right? So, yeah, that's it from my side for today. I'll invite Sachin to take over and then start with his talk. Yep, sure. So yeah, we'll do the setups and then we'll get started. Give us about 5 minutes and we'll start at about 11:30 with about XC vulnerability, and Sachin will be talking about it. Thank you. Thanks, everyone.
क्या वाईफाई है यार grab dax grab x grab board grab board
Okay, just 2 minutes. We are just setting up, so please hold.
some reason my thing doesn't resolve conf doesn't work that well. Oh, खुल रहा है. It takes some time to get out. Ah, yeah. Well, browser takes a bit time to open up.
For people who are here for the first time, Team Water are to your right.
लोग ऑफिस कहाँ है ग्रैब का ऑफिस कहाँ है ये दिस इज द ऑफिस थर्ड फ्लोर ओके क्या है रिफ्रेश करो कुछ नहीं मोबाइल से देता हूँ तो। मोबाइल पे कर लेता हूँ। नहीं यार वो पीडीएफ। वही कर रहा हूँ। मेल में तो घुस जाऊँ। नहीं नहीं किया मैंने मेल, अभी सवेरे ही बनाई है। तो हल्ला करेगा। इसको भेजनी है। आज ये क्या हुआ? reb.com। अनिल देखो मिल गया। आ गया होगा। 4 MB की फाइल है। एक्सम स्पेलिंग गलत हो गई है।
कोई नहीं ना, मैं क्या करूँ?
नहीं नहीं ठीक है वो विल फॉलो। वाईफाई कनेक्ट करके आया अनिल। anil.yadav@grab.com। दूसरा क्या LSP वाला? हाँ हाँ करो। हाँ पर्सनल कर दो। सॉरी सॉरी। Hello, can you hear me? Fine. Okay. Good morning, everyone. Yeah. Oh, yeah. Okay, fine. Yeah, this is the camera. Huh? Okay, fine. Then it's good morning, everyone. So you're online. Have you started? Okay. Still, let me know. So they told us that we are now live. Good morning, everyone. Great having you guys here on a June Tuesday. So my talk is going to be about the exit vulnerability that you might have heard about, the exit utils vulnerability that came out in the month of March, late March, end of April. And it's been a pretty severe. We are now live. Good morning, everyone. Great having you guys here on a June Tuesday. So my talk is going to be about the exit vulnerability that you might have heard about, the exit utils vulnerability that came out in the month of March, late March, end of April. And it's been a pretty severe. Sorry for that. एक मिनट का lag है. Yeah, okay. Sorry for that echo thing. So, as I said, I'll be talking about the exit vulnerability that came out, a pretty severe vulnerability, and it's really an issue about malicious people putting in backdoors, and that's what we'll discuss, how the backdoor was found, what it was, and a brief idea about what it does. So I just got a small slot, so, and I haven't, it's pretty technical at this, so I'm going to skip all the gory details. There are lots of people on the web who have done a section of the problem, and also I'll basically just be pointing out to what it was all about and where to go. Next slide, please. Next slide. Yeah, next slide, please. So these are the three things I'll be talking about, what the vulnerability was, what the techniques were, and what have been the learnings for the community. Next slide, please. So this is what the news was around the web in the month, at the end of April, at the end of March or April, about some headlines that what we know about the utility, and that's how I got interested into it, trying to understand. I'm not a security researcher, so I didn't really give a lot of thought to what it was. But it so happened that there was a LinkedIn post that came up to me where somebody said that software bill of material techniques will not have solved this problem. That got me a bit intrigued because I was trying to look at what the SBOM thing is and what a secure software bill of materials strategies people are employing. And so I asked, and then they pointed me to the direction that there was a vulnerability which was due to a malicious actor, and so hence this. So that's how I got interested into it. Next one, please. So firstly, what is exit utils? Exit, as we know, is a lossless compression software. As we would know, compression is of two types, which is one is lossless and one is lossy. JPEG is an example of a lossy compression where not every, MP3 is lossy, where you are actually losing some amount of fidelity in information, but you are able to essentially get this roughly the same thing. But for most of the software that we need, if you want to transfer files, we do not want any loss of information, so we use lossless compression techniques. So lossless compression techniques are gzip, bzip2, PNG also is lossless. So lots of these are there. It implements the LZMA, that is Lempel-Ziv Markov chain algorithm. Compression is a complex business. It requires a lot of information about what the data sources are, how do you encode them. It's large-scale signal processing and all. Actually, there's a very nice book, I don't know whether it's still in print, by Nelson, who's talked a lot about all these compressors and all. It has higher compression rates than the alternatives, as you can see. The Linux kernel, 1.6 GB compresses to 222 or 137 MB, almost 38% smaller than gzip. However, its decompression speed is less than gzip. So it's slower than gzip, 23.4% that should be, sorry. And its compression speed is much, much slower than, it compresses much, much slowly than gzip does. But its decompression is faster. And because of the significant file size changes, that's one of the things why it is one of the preferred compression if you have the memory and the processing speed and you're just going to compress it once. And like the Linux kernel, you just compress it once and it gets decompressed multiple times, so it saves a lot of bandwidth, transmission bandwidth and things like that. The latest version has been released on 29th May 2024, 5.6.2. This was after the backdoor was found and resolved. The backdoor was found in versions 5.6.0 and 5.6.1. These versions did not make it into the stable distros, but it came out into Rawhide, Fedora Rawhide 41. And if I'm correct, I didn't look at it, but possibly, which one is this? The one that Arch Linux and all the bleeding edge distros would also have gotten that. Next slide, please. So what else? So this vulnerability is CV 2024-3094. It has a score of 10, which is the highest in this common vulnerability scoring system. Yeah. Oh, fine, thanks. Yeah. It was discovered, as I said, in late March 2024 by Andres Freund, who was a Postgres developer working at Microsoft. And interestingly, the thing that he says, he got it because he found that SSH logins were almost 3 times slower on a system which was linked with the new LZMA. Why SSH was linked with it is what we'll get to also, compared to what was earlier there. And this is his tweet on 30th March. It's pretty small, you can't read it, but essentially he says that I found that this was there. I also found that Postgres was having some problems. I ran it through Valgrind. I found lots of process issues, lots of memory, CPU cycles being used. And so that's how he dug into it and figured it out that it was basically because of the new version of LZMA that had been linked into it. The reason it uses SSHD is it gets impacted is because it exploits the systemd notification system of SSHD. SSHD has a notification system where it tells systemd that, okay, I'm ready. And systemd actually links into libLZMA for its decompression, its journal. So systemd uses libLZMA, the exec algorithm, and OpenSSH uses on certain distributions, and that's how OpenSSH became impacted. This is a sophisticated exploit, which actually is pretty interesting because it's not just the typical exploit that people say, a stack smashing exploit or a buffer overflows and all of that. It basically uses various runtime, build time, and linker techniques. So it is at all levels it has been done. It uses a compressed binary as a thing, which is an obfuscated shell script, which had been uploaded as a test file. In a test file directory, they had uploaded a particular test file, which they used at build time, and it and the interesting thing is that this is actually a very great example of how social engineering had happened in the open source community, where certain malicious actors have been able to gain access to and get commit privileges. And there are lots of people who have written about it. I didn't get the time to go through all of that, but the idea is that there's this guy called Jia Tan who was trying to get some commits done. He was giving some small patches and all. Then there were other people who were sort of saying, yeah, great work, great work, great work. So there was a social standing that was built around this guy. And because he was doing good work, they gave him commit privileges, and that's how it happened. So what are the techniques used? Briefly, at build time, it says that, sorry, it's too small, but the essential idea is that if some preconditions match, it modifies the makefile to target only the x86-64 Linux, and if it is being built with the GCC and the GNU linker, it injects an obfuscated script. Now that script is actually, if you look at, I'm sorry, I didn't realize it would look that small. It's basically a lot of head, and the script is essentially written in a way that you can't really make head or tail out of it. When they decrypted it, it's basically a lot of set of environment variables and a lot of if statements which come out. This file also contains additional binary data at the end of it, which there's an awk script which is embedded inside this script which extracts that binary data, creates it's a 64-bit relocatable ELF library, and that gets linked into the lib-lzma. So you essentially created a test file. Within the makefile, you were able to inject certain cases where it did extracted out this obfuscated code, decoded it, and then at the final build level. And another interesting thing it did is whenever it was doing this stuff, it created hidden directories, .libs with a dot, so that people would not know about it. And in case the build fails, it would delete all of that. These standard makefile practices. We don't want clutter around, so we do that stuff. So the interesting thing is that all of these things that normally people expect, people don't really look at the build outputs or the makefile outputs or what really is happening very, very, very carefully. And those are the things that taken advantage of. Then the link time is that it adds up being loaded in OpenSSH and certain distributions. As I said, it is about the systemd notifications, which in turn depends on lib-lzma for compressing journal file. Now, this is an interesting thing. It doesn't really directly uses it, and it uses the specific linker loader ideas about indirect function calls, where the function call gets resolved at runtime. And it does that. It provides its own version of two function resolvers for CRC functions. And the interesting thing is that it does not use, while lib-lzma does not use indirect functions, but using faster functions, it does sound like a plausible thing. And then the exploit itself, the name of the file is CRC64 fast. So if anybody would look at it, they would just think about it, that it's a faster version of doing a CRC summing, and hence people would overlook it. So while at runtime it looks at it, and then this I mentioned, but at runtime it even looks and checks whether it is running against OpenSSH, or there are places where if it has been invoked and OpenSSH has still not been called, and because it's a complicated way, the function tables, pointer tables are there. Only when it gets loaded, so there are ideas about audit hooks, and so pretty complicated ways of, lots of advanced linker functionality is being used to make it run at link time and runtime. And then the interesting thing that I came across was to prevent detection. As I said, use hidden directories while building, use obfuscated code. And the other interesting thing is that it did not embed any strings per se. One of the first things we would do is like run the strings command to see what are the embedded strings and figure it out. It used a trie data structure, which is basically an index tree where any string, as you can see, if it is A, L, T, and also first alphabet, then second alphabet, and third alphabet. So the data structure, the string static data was itself embedded in a data structure so that you could not extract it and see that where this thing is coming from. And last I read, they were really unsure about what the backdoor was really trying to do. But one of the things is it was trying to, if you do an SSH, some specific systems to try to connect. And so that I'm still not because the interesting thing is that possibly the backdoor was caught before the end thing could be, because it was caught much before it could go into the main distros and everything. So possibly the entire the infrastructure was not in place to be able to catch what was it. So it was trying to extract stuff from specific certificates that would be there and try to do some malicious activity there. Then what are the learnings that I think? Firstly, that's what, back to the basics, we really need to be cognizant. The build systems have become really complex. Because we need to support multiple platforms. And because multiple platforms have their own idiosyncrasies. So if you just do a configure or make, you would say, I'm checking for this, I'm checking for this, I'm checking for this. And auto make and because of this, autoconf and automake that are largely used are not very well understood. And very few people are really able to write their own auto configure files, understand what are the idiosyncrasies and things like that. And because of the autoconf and automake are not very well understood, the upstream actually ships tarballs which are configured for a particular, the makefile is generated for a particular host, and that gets shipped, and then you build it. And this is what actually happened in this. It was the tarball that was shipped that had those lines in the makefile that allowed the malicious code to be injected. Per se, the auto configure and automake, if you look at it, they did not have it. So if you would do this by yourself, if you would do it, it would not possibly create that. But it was because for particular distribution and all these things came together, it was configured in a way that then this tarball was shipped. So the code was possibly not even in the code repository, but possibly injected later on. And then the tarball was uploaded. So that's a possibility. So so there are a possibility where you do an automake, configure, build, make file, and then you inject 2-3 lines into that make file, and that make file is what you ship to the downstream check-in. Then there's a large attack surface, I said, OpenSSH links with systemd, which links it. So which is an interesting thing. Why OpenSSH should link with systemd was a question that we had. Leonard Pottering posted a thing that, no, you don't really need to link the library with systemd for notification purposes. There are other ways of doing it. Well, I don't know. Systemd to me is an abomination that I try to avoid if I can, but well. Then social engineering, as I mentioned, Jia Tan was the name of the person who did the malicious activity. He got commit privileges after years of work. There were lots of online profiles that were praising his work. So there was this term they used called sock puppetry, basically false personae that were coming. And the interesting thing is, because you are in a place where you don't really know people well face to face, some people don't come about. We don't even know who created Bitcoin, for example, till today. So, and then the software bill of materials is not a solution because, as we discussed, we are trusting the people who are putting in the code. So whatever software bill of materials it says it's coming from the trusted thing, that will anyway go in. So malicious actors, to prevent them, we need other ways of doing it. So basically what I'm saying is continuous code review. Whenever you do a build, you try to understand what is happening really and what if data is pulled in, then all these test files that are there, all that. So it's actually a pretty complicated way to be able to, if you cannot, actually will not be able to get any work done if you really try to check all the boxes and show this. So that's all. Thanks a lot. Anything? Any questions? Yeah, please. Yeah.
And most of the every company picks up OpenSSH and have their own SSH servers and clients customized, modified. But I do see that neither Ubuntu nor Red Hat nor SUSE has told that Tumbleweed has this vulnerability which they have fixed. But rest all have said that yes, it is a NC which is high, but it is not affecting any of our versions.
So the reason for that is that the particular versions where this vulnerability had been found, 5.6.0 and 5.6.1, had actually not been shipped in the distributions, the stable ones. Rawhide Fedora 41 had it, and whatever this guy was using, I don't know. And then Ubuntu 24.04 was also planning to put this in, and hence they delayed it.
It's not yet launched. 2404,
I
right?
thought it was 11th April. I didn't follow it.
No, it's still in alpha. It official launch.
Yeah,
is
so I
yet
think this
pending.
has been one of the reasons why they had to delay it, because of this particular bug was being found. So most stable distros were still not shipping this. 560 and 561 had been shipped by the unstable bleeding edge distros, and they basically have been reverted back. So everybody was told that you revert back to the, because they found out that this came out only in 560 and 561. Before that, it was clean. So earlier versions in 5.6.0 were cleaner, and now 5.6.2 was launched about 29th May, as I said, which I think has ensured that this vulnerability doesn't
So
exist.
any thoughts on as to what was that change in your research? Did you find anything which they said that 5.6.5.5.9 or something doesn't have it? And what was the change which?
So the change was that this particular code injection techniques that were being used had been done for the 5.6.0 version. So possibly Jiatan had not gotten commit privileges earlier. He got this now, and then he worked on it and did it. Then another thing is that there were other things that are there there were other changes that he made, which had not been pulled in, which were doing something other funny stuff on that. And then there was some sort of a similar commit, I think, in the kernel tree also. Some things were there. So this guy is pretty suspicious, and that's where the suspicious comes to state actors. So there's a big suspicion pointing towards China, for example, that it's the Chinese government, because it's a pretty sophisticated attack. It cannot be the handiwork of one or, and the whole, as we talk about it, the whole social engineering thing, everybody praising him for his work, he's done a great work, then so people may be putting in possibly some bug report or something, then this guy might be solving. So large way of trying to build a standing in the community where you can get committer right. So, and why choose the compression software? I think now that I'm thinking, it's because that's the best way to, you have a test file which you can upload binaries as test files, because you can say whether it got extracted, and then if you know the path, so it is used everywhere. It's possibly also used in the kernel. I can also do kernel xz compression, but kernel code, I think, for compression and all is different than the other one. So, anything else?
Questions?
Thank you. Thanks, everyone.
Thanks, Sachin. Thanks for the great presentation.
Thanks, Sachin. So our next speaker is Avikalp, who will be presenting about how to do code review at scale. Yeah, so over to you, Avikalp.
Hi. So when I was preparing for this talk, I went through the topics of all the talks of LSP in the last 30 meetups. And I noticed that there was not even a single talk about code reviews, which was extremely surprising for me because I don't know of any large-scale production system that is built without code review on every stage. But this can be a good thing. That this talk has come probably at the perfect timing, because now more than ever code reviews is becoming a bottleneck, especially because people are using AI to write the code. So before we start, I just want to get to know you guys a little bit better. So can you show with a raise of hands how many of you have written and shipped any code this week? Okay, not a lot of people. How many of you have reviewed at least one pull request in this week? Yes, a lot more. Among the people who have reviewed any pull requests, I want to know if you start with the author to understand what's going on with this pull request. Raise your hands if you did actually sit with the author. Okay, you did it independently. Great. And raise your hands if you actually pulled the branch locally on your computer to thoroughly check it out. No, just on the website interface. And finally, raise your hands if you feel responsible if anything goes wrong in the pull request that you approved. Great. So this is the right audience for me for this talk as well. OK. So just to establish some common knowledge so that we have the right definitions for the right words, you all must be aware of what Git is, right? It is a version control and collaboration tool built by Linus Torvalds, who also created Linux. And this amazing tool gives you the magical ability to do time travel in your code base and even traverse parallel realities and merge them at your whim. This amazing open source software is generally paired with a code hosting provider, something like a GitHub, Bitbucket, or GitLab, which helps you put this Git repository on the cloud to help everyone else access it. The most important feature over here, which I'm sure you are all also aware of, is the pull request, or the merge request, or code review, whatever these websites call them. And this one amazing feature helps you propose changes to the code base that other people in the team can actually give you feedback on. Right? And this feedback is what we'll call code review for the rest of this presentation. Great. OK, now let's answer the first question. Why do we even need code reviews? Especially now, there are so many tools, so many AI tools that can perform an automatic code review by themselves, right? But still, our teams, get behind us in getting a person to review. They would have code owners, or they would have, a rule like at least 2 approvals need to be done in order to get merged, right? Why do people have this? To get into this, let's go back to the birth of pull requests. So before tools like GitHub existed, people were still working collaboratively, right? In fact, let me just share a terminal here. So here I'm in a Git repository. Like I can just do a Git status to show you that. Right now, there's it's not a popular command anymore. But if you look at your own Git remote, you'd probably just have one origin which has the URL to the GitHub or the Bitbucket repository. But this feature was more than that. Earlier, before GitHub, people would have the entire list of all the people who are contributing to this repository over here in their Git remote. I'm sure people who are veteran users of Git might be aware of this. I myself have used this feature a lot back in college. And then Git also has commands like request pull, where you can just specify the commit ID or the branch along with their URL. And it will create the entire block of information that is required to give the context to someone who is reviewing your pull request. In fact, many of you might not be aware that Git also has a send email command inside it, so that you can send the last commits in your branch as email to the person who you want to get a review from, right? But this has been 15 years that people have been using tools like GitHub. So actually, Git removed this command, it's not there anymore, but it still comes on autocomplete. You can still see this in their manual page, right? So this kind of shows you why we had pull requests or code reviews in the first place. And that is for control. The person who owns the repository, the origin, wants to know everything that is changing in their code base, right? This is like the primary meaning of what code owners mean. If you have a code owner's file in your repository, can you show with a raise of hands how many of you have repositories which have a code owners implemented inside of it? Many of you. When I say code owners, it should ideally mean that without their approval, the PR will not get merged. And the approval should come from every one of the code owners, right? If only one of the two code owners actually review or approve it, it's not really a real implementation of control. In that case, what you are actually doing is just a knowledge transfer. And this is, I think, the most popular way in which we use code reviews these days. It is for knowledge transfer. I think a lot of you would have, can you just raise your hands again? Sorry for that. If your repository has a rule like at least X number of approvals are required before it is merged, right? Why do you need at least X number of reviews? It's to establish knowledge transfer, a way in which other members also know what's going on in your code. Here, if you look at it, it doesn't just do dependency resolvement. Like it's not just for so that there's no dependency on one person. It also helps in other manners. For example, if you are someone who constantly reviews other people's pull requests, you would be more flexible. You will be able to work on any part of the code base. You'd also get higher speed in your deliveries because you will not be blocked on someone else to help you understand that code base or to work on that code base on behalf of you. And one of the most important things that I think, I saw someone who was wearing an on-call t-shirt over here, right? It also helps you when you're on call. If you have reviewed the pull request in a particular module and something breaks when you're on call, you can focus on actually resolving that issue instead of traversing the code base and understanding where the issue is coming from, right? This finally brings us to the third and I think the most important part of the code review, and that is readability. When we talk about code quality, this is, I think, what we are actually talking about. We use a lot of automation tools like formatters and linters to keep the code readable. We also follow and preach about KISS, dry, and solid principles, which are primarily just readability things that help you maintain readability in your code base. We also follow patterns like never nesting or separation of concerns in order to keep the code readable and keep it modular. Now, all of this is just to help us keep the code easier to understand, modify, and reuse later. We maintain this modularity because we know that lesser code means fewer bugs, and fewer bugs means better performance and higher speed of the team. And that is like the final reason why we do code. It is to maintain correctness and performance. I think if the lib-elzema team would have done code reviews very well, as I think Suraj also mentioned in this talk, that is one of the reasons why this exploit was even possible, is because they did not understand the changes that were proposed very well, and they merged something that they did not completely understand. And this particular statement that I said kind of magnifies how important we think correctness is when we are reviewing code, and how low an importance we give it when we are actually reviewing it. If you think about it, the code review interfaces of GitHub and Bitbucket and GitLab don't really help you maintain correctness. For example, if someone has changed a function signature, the code review interface doesn't really show you where all was this function even called, right? If the person has only modified 2 calls and did not modify 3 others, your code will break in production. And the interface doesn't really help you figure that out, right? And performance also, like it's extremely difficult to understand whether the new code is going to lead to a lot of performance issues or will it not lead to any performance issues. Sometimes we would spend time even over-optimizing some things because we think that it should be performant, but it is not really needed because that code isn't really called that many times, right? So Nevertheless, we try to catch any mistakes there are there and try to optimize the performance as much as possible. So let's revise. What are the main reasons for code review? The top reason is control. The second is knowledge transfer. Third is readability. And the fourth is correctness and performance. Now, you might seem that your team kind of has the perfect code review process in order to make sure that speed is maintained and all of these problems are not amplified. But let me ask you this question. The last time you raised a pull request, how long did it take you to actually get one proper review? How many hoops did you have to jump? How many times did you have to go back and forth to re-implement the same feature before the pull request was merged? Why did you have to sit in a meeting with the author of the pull request to actually review it? And how many times have you been blocked on someone else in order to ship your own feature? Right? If none of these things frustrate you, maybe your company has figured out the perfect way to run a code review. But if it has, please talk to me after the talk. I will want to study you much more deeply. But I have interviewed engineers of over 100 companies, big and small. And it turns out that it is solved nowhere. Let's consider the case of Lenskart. I have been working with them and to solve their code review issues. So Lenskart has a very ambitious tech leadership team. They have a release cycle of twice a week, which makes speed everything. They measure everyone and every tool based on how much it helps them increase their shipping speed. To get a pull request merged in the Lenskart repository, first of all, your code must build successfully. But after that, you need two approvals. One can be from anyone in the team, but the other one has to come from a predetermined list of pod leaders. Now, what is the problem here? There are actually two problems. One, if you talk to any engineer in Lenskart, they would say that they struggle to get anyone to review their PR. They need two approvals, and they can't get one. Why? When they raise a PR, the automation tool automatically assigns the pod leader there. The pod leader is so busy with other pull requests, they don't take a look at that. So they post the link of the pull request on the common Slack channel, thinking that someone might find time and go and review this. What ends up happening is everyone is busy, and they think that someone else in the group might end up reviewing it, so why should I? The PR still doesn't get reviewed. Finally, this guy finds someone in that list of pod leaders and someone else in the group who they have good rapport with. This has nothing to do with the code base and how well they understand it. It's just a social thing. How good a rapport they have with them, they will just DM that person and get behind them to get the pull request reviewed. Now, because this brings us to the second problem. Now, because this person doesn't really understand what's going on underneath, most of the times, the code is huge, right? The code base is huge. A good analogy is that if you get 6 blind people to tell what an elephant looks like by touching it, someone who's touching the ear would say that it is a thin, flappy piece of skin. Someone who's touching the leg would say that it's a thick pillar. But no one actually gets the whole picture. And that's how engineers are in their code base, right? They don't really nobody really understands the full picture. So there's a very high possibility that the person you brought in to review your code doesn't really understand the code that you are altering, right? So what they will do, they'll ask you to explain it to them. Now, if you are explaining it to them, they are not really validating the readability. They are not enforcing any kind of control. And it's very difficult that they would have any estimate of the correctness or the performance of your code. Right? It kind of defeats the whole purpose, and the only thing that is still taken forward is knowledge transfer. They understood from you what you've done. That's it. Right? So how do other people deal with this? So let me take you to a conversation that I had with my friend Hardik. So Hardik is a CTO of a very successful startup called Friend, FRND. And we were just sitting on a Saturday afternoon in Dew Art Cafe in Kormangla. And we were geeking out. We are just friends. We were just geeking out about random coder stuff, like why Python sucks and why Rust is so awesome. And in that discussion, we ended up talking about why we love monoliths. We both really loved monoliths. how easy it makes it to navigate and search different things in the code base, and how managing versions across different services is so easy in it. That's when he dropped the bomb. He said that as a CTO, because he's expanding the team right now, he's moving from a monolithic architecture to a microservices architecture. I was so shocked that the only words that came out of my mouth after a pause of 30 seconds was, "But why?" And he said that it's nothing to do with the systems, actually. It's not something related to the scalability of their systems, because the cloud kind of handles it pretty well for their scale, which had like around 20 million daily users. His problem was so the requirements for new features and changes come vertically, meaning that they are functional changes. To complete one particular feature, you actually have to touch every part of the code base. And this was leading to a lot of confusion. People were overwriting each other's code, and nobody was really aware of what's going on anywhere. And this is why he wanted to break this application down into services, and so that he can tell small teams to completely own a particular service, so that there's no confusion on who should I talk to if something is changing over there, or if who should even be allowed to change something. Now this kind of reduces his cognitive overload in team management, but this leads to problems later down the line. I was interviewing an engineer from Geeks for Geeks. I'm sure you might have heard of that company. They have a pretty big engineering team, around 70, 80 engineers, with four big silos in them. The engineer that I was talking to, when I asked him what is the most frustrating part of his job, he said, waiting on others. Because he did not own all the services that need to be altered in order to ship his feature, he had to wait for other people to implement them. And it was never the highest priority for that team, right? So he had to wait weeks, and he had to come back to this feature again and again, stashing his previous changes, going back to the previous branch, and adjusting things so that their work is not hindered, so that they deliver what he wants to ship his feature, right? This is the kind of problems that people end up with if they implement such kind of silos. So this scoping also does not really work at scale. Now, when this problem is big enough, if you are working in a large-scale organization, I'm pretty sure that your company has put in a lot of energy, resources, and created tooling in order to make it easier for you. I'll give you an example of Microsoft. So Microsoft has two internal tools. One is called Ownership Enforcer, and the other is called Merlin. The Ownership Enforcer, for every pull request, it calculates dynamically who are the right set of people to review this particular pull request. Why dynamically? Because when you look at a static code owner's file, these people quickly get out of touch. They're reviewing so much code and they're writing so little that the next time they look at a pull request on the same module that they reviewed earlier, they don't really have the full context. So you actually need people who understand that module very well to review that code. And as your team evolves, as your code evolves, as you add more members to the team, the same person who's added in the code owner's file is not necessarily the best person to review it anymore. So they have this code ownership enforcer within their system, which dynamically finds out the list of best people to review a pull request. And it uses a round-robin algorithm to identify two people who are the best people to review this code. It assigns them as reviewers, and it doesn't let you merge the pull request without their approval. Now, this is great, apart from the round-robin thing. So the round-robin thing just means that someone will do it. It's not really a smart algorithm. The other tool, Merlin, what that does is it follows up with just those specific two people on email to get their review. It also does other things. It makes sure that all the other checks are passing, the CI is running, the build is running, tests are getting passed, all of those things as well. But this is like the main feature that people remember it by, that it follows up. If I have to review a pull request, it sends me an email asking me to review that pull request. So I actually remember to do it, right? The thing is that this also becomes spammy very quickly. And they're constantly working on this algorithm to make sure that there's little spam. If there's too much spam, people stop reviewing again. You receive 10 emails to review pull requests in a day, you review none of them. If you receive 2, you might actually look at them. Right? The experience of engineers in Rubrik was a little bit better. They used Slack for this, and their algorithm was a little bit more smart, so it was a little bit less spammy. They were pretty happy that there was no spam. Whenever they would get a Slack notification to review a pull request, they would just go and review it. And the person that I was talking to was an engineering manager, and he basically said that reviewing code is part of my job description. It is basically the first thing that I do every morning, and as soon as I get a Slack notification to review, I am there to review that pull request. So there, things were a little bit more smoother. If you look at what these tools are actually doing, it's 3 things. One, it is a lot of automation. Things that help you maintain readability, which can be enforced as rules. These tools actually put them in, like formatting, linting, CI/CD, static analysis. It helps you get through a lot of back and forth iterations without having to involve a human person to review. The second thing that they do is dynamic ownership. And the third thing that they do is non-spammy communication and follow-ups. But there's still something missing. Even for them, reviewing a code is a heavy task. It's a frustrating task. It takes a lot of time. It's not necessary that you will actually be able to understand it. And I think that is the one thing that still needs to be built. That is a way to make it easier to understand the pull request. Among my interviews, the average amount of time that a reviewer takes to understand a non-trivial pull request is somewhere between 20 minutes to 1 hour. That's a lot of time commitment. If you have other tasks on your plate, you'll probably want to move this behind. You want to take it up some other time when you're freer. Right? That's why people are not taking the initiative to actually come up and review code. They also don't know whether which of the pull requests actually need their attention, or they would actually understand them. So that kind of becomes a big bottleneck. That's why I propose 2 things to make it easier to understand. One is adding context. If when coming on a pull request, you already know what is this for. A lot of people link Jira tickets to make this easier, so that at least you know what this author is trying to do. Right? But then there is more to the context. It's not just about what is this person trying to do. It's also about what the current code base that was being altered, how was it interacting with the rest of the system? What was the traffic at different parts of it? How critical are certain systems compared to others? Without all of this information, their review is actually not that good. And the other thing is personalization. If you don't have a personalized context management, either give too much information that person will not actually read it through, or you will give too little information that it will not be enough for someone to understand what's going on. Right? So personalized context is something that I believe that still needs to be added on code reviews. And actually, that is what I'm spending all of my time these days. I'm creating a tool called Webinex that currently just has 2 things. We have a lot of features in the pipeline, but it kind of, first of all, does non-spammy communication. So if you have a pull request, it adds comments. It adds a comment telling you who are the relevant reviewers in this and what is their relative relevance. This also helps someone who wants to review, but there are 20 pull requests open. Which one should I review? It answers their question that, OK, you are 70% relevant for this pull request. You'll probably give your time and attention to this one. And it also adds them as reviewers. And in the future, it will send emails or Slack notifications as well in order to follow up with them so that they review this pull request. And the second thing it does is personalization. On the code changes view of GitHub or Bitbucket itself, it highlights the files and the changes that this person has previously worked on so that they can navigate the pull request in a manner that makes sense to them. This is just the tip of the iceberg. We just launched this in January, and a lot of things are in the way. And what I really want you guys to take away from this talk is 3 things. The next time you are at work, I want you to take initiative in reviewing pull requests. You know from your experience that how frustrating it is if you have raised a pull request and it takes a lot of time to get that PR merged. Right? So take initiative. Look at the pull requests on your own. The second thing I want you to do is please don't sit with the author. I think most of you already follow this. But if you sit with the author, you are not really validating the readability of the pull request anymore, right? You're just hearing their story, and kind of you are kind of biased when you're doing that review. You might end up skipping certain things and letting security vulnerabilities inside your code. And the last thing is, because this can make your code review a lot more challenging, use processes and tooling that help you understand the changes better. Get the author of the pull request to add context about your pull request on the review itself. Communicate with them in order to make sure that it's easy for you to actually review it. So we are building this open source, the WebNX platform that I'm talking about, right? And I'd want you guys to come and join us in that if you're passionate about code reviews or if this is something that is frustrating for you. This we think is going to be a bigger problem in the future, especially with AI doing a lot of writing work, and especially because the main job of, like, it cannot really be automated. Reviews have to be something that humans have to do. Without that, there's no knowledge transfer, there's no control, right? My contact information is on the screen. Please reach out to me. I would love to talk to you and understand this further. Thank you. If you have any questions, yes.
First thing, let me clarify why you didn't find anything about PRs and all in this. The abbreviation of LSP is large scale production engineering.
Right.
Now, production engineering is after the software is built and delivered to production, not before that, right? So production engineering is about managing, maintaining, and making sure production systems and everything is running perfectly fine without any issues. If any issue comes, that will be routed to the software engineering team. So your topic is about software engineering. That's why you never found it in any of the talks out here, right? Secondly, I would like to ask you, your code directly goes to production without hitting any of the pre-prod or any other systems?
No, obviously. There's a staging, there's a pre-prod environment.
So if that is the case, then all your stuff should be caught before even it hits the production, and your statement that it can bring down the production or have stale code in production can be caught in the previous stages itself.
So you're talking about correctness over here, right?
No, I'm talking about why, if you are saying it is hit, it is going, the bad code goes into production, that means your system of evaluation is wrong, or your systems are not correct before production, or they are not same as production.
When you say bad code, a lot of what we define as good or bad code is not really about the performance of the code. It's about how readable it is and how easy it for the others to maintain it.
See, that also comes in line with people, how they understand. If you go and give code to a means project manager or program manager who knows nothing about coding, then you are not doing the justice, right? But if there is a senior developer or a coder who has been involved in the project from start, he understands what you are writing. So definitely you don't really need to explain to him as to what, or if in case if he asks you to explain as to what you have done, he very well understands, very well knows where to catch you, right? So saying that PR, people asking people that we asking, or the code reviewer asking the person to read it out, that doesn't mean that he's not listening. He is mainly intending to see whether you are able to catch the problem or not.
See, I understand where you're coming from, but the bias is real. In fact, so open source repositories follow, I think, the best code review practices out there. And this lib-elzima example that Suraj mentioned. In his talk also, like one of the 4 pointers for the next steps is to have a better understanding of the code and to do a more thorough review, right? You're saying that what you're saying is true when you look at it superficially. But someone who is not working closely in the code base, even if they have heard from other people what's going on for a long time, if they don't really deeply understand the code, which is often very difficult if you are not the one who's creating it, then you will miss out things.
But you know that, right? When the code review and PR reviews happen in open source environment, they run against automated systems, test cases, test builds. First, you have to write the test code, right? Even the peer review has to pull, write the test code, run it against the tests, and then then if it's certified, then, and that goes through multiple stages of code review, and then only it'll after testing and everything is found to be fixed, then only it goes into the even open source repository for production live mark test bug fix. Otherwise NCEs and CVEs, they will catch you, their systems will catch.
Correct. Yeah, the thing is that these systems are not perfect. There are gaps. No matter how much testing you do, you'll not be able to capture everything that someone who just understands the code more deeply can, for example, discover.
Then that is the human problem.
Correct. That's code reviews are primarily a human thing. If
That's why the person is asking you to explain what you, because he wants to understand what you were thinking in writing the code, not what I think and expect you to write a code.
all right, I think we can take this offline. But the thing is that finally, the code that is being written has to be interpreted by the computer, not another human being. So even if I understand what you were thinking, it should fit with my model or what we had discussed beforehand, what we had discussed in the planning meeting, right? That this is how we want to execute it. And if I come from bias, I'll not be able to do that understanding my own.
Dynamic ownership, which obviously makes a lot of sense because, like, in our case, what we do is we usually have the on-calls who are primarily responsible for reviewing the PRs.
Right.
Because in some cases you have mono repos also wherein you're dealing with code,
Correct.
right? And the other one would be context. And I think, as you rightly pointed out, at times you also want to get some context with respect to how the code is performing. So you won't just blindly go and update it also, right? I mean, you won't just
Correct.
review it. You would still ask for a lot of testing validations, or at the most, in some cases, even on the PR, you would ask for results. If at all you're
And not just testing. Like if I'm sure you would be sitting on call and looking at New Relic or your Grafana dashboards all the time, right? The things that you look the dashboards for, you have a much better understanding of how they're performing in production.
True, but again, as he said, that your code won't make it to production before having to go through all the trials of running through different environments, right?
Correct.
And you also have a lot of your, CI built into it, wherein you're doing a lot of this testing and E2Es or functionals or whatever that you want to do. So, I mean, yes, it does speed up the process. I'm not going to disagree there. But calling it on the whole as a problem as such could be a far bigger statement, I guess.
It might not be a problem from the point of view of are there bugs and errors in the final product. These are problems from the developer's experience point of view.
Because even after all of this, you still have cases wherein a buggy code does make it to production. You still have,
Correct.
Then you have to do an hotfix. And
Correct.
whatnot. So yeah.
I agree with you. Like, so what we are actually trying to, my whole, the whole year that I've been spending on discovering and understanding this problem better is from the point of view of a developer. If the developer experience is filthy, it's not good, they'll have like more, there'll be lack of judgment at various points. There'll be, lower intensity of ownership. There'll be more mistakes if you don't make the experience good. So that's like the base of all of this conversation.
Tools like Copilot and Codium. So explicitly now the developer doesn't need to bother about look and feel. You just start it, it'll finish it and give it to you.
Correct, exactly. But that's all the more reason. So I was talking to the head of engineering at Khatabook, and he had allowed the use of Copilot in his team. And one of the things that he first, saw internally, and then also read a paper about it afterwards, was the more people were using Copilot, the lesser they were actually writing modular code. Yeah, but more code means more chances of problems.
In a high-speed running world of AI and ML now, you have less amount of time to deliver.
Correct.
Right? And modular code, you need to know that is expected out of you as a college grad. After that, you're supposed to, you need to understand what it is going to be done. So your logic and understanding is more important than the content which you're writing, because now that content will be delivered as per your expectation. Why? Because you still have the judgment to do that, whether this method is right or not, whether
Correct.
this particular, whatever variable the the tool is suggesting, is it what I want to select?
You're correct in
You're
that.
still, so the human factor is still there, but it is making your coding faster
You're correct in
with
that.
all the annotations and
I'm
explanations.
actually trying to help that even further. If you are able to catch those things in the review,
If you
it
make
will be,
everything easier for others, then what will humans do? What is the developer going to do?
they're
You
going to
need to keep
review.
something for the developer to do it, right?
They'll
He is
review.
getting paid for it.
That's what the developer should be reviewing. That's like the primary core thing that they'd be doing. Machine will be writing the code and they'll be reviewing.
Let's take it later on. You can connect and
Cool.
you can discuss more. Thank you. Thank you.
Thank you.
Thanks, Abhikalp. I hope I pronounced your name right.
Yes.
Thank you. Great presentation. So next we have Samit Singh from Grab. He will be presenting on developer self-service. So he'll be coming on. So last talk, then we'll.
Hello. Hello, everyone. So, thank you for being here. This is my first time presenting in LSP, and I'm attending the LSP for the first time as well. So, kindly bear with me. So, in this talk, we'll be discussing about developer self-service with GitOps. Sorry? Louder? Okay. Okay. It's okay. Hello? Is it better now? Okay. Thank you. So in this talk, we'll be discussing about developer self-service with GitOps. So before going ahead, I just want to introduce myself. I am Samit Singh, currently working as a senior SRE at Grab. And if you want to reach out to me, you can connect on LinkedIn. Okay, so I believe everyone might have heard about self-service. Most of you might be already using it. So just wanted to know how many of you are already using self-service for, say, provisioning your cloud resources or maybe deploying something to your production environments, dev environments. So can you raise hands if possible? Okay. Okay. So before jumping into self-service, I just wanted to tell you a little background, right? Why we needed self-service and what was the requirement. So suppose a developer comes to SRE or DevOps or maybe some other team which is responsible for managing the resource or deploying it to cloud. They're asking and coming, okay, I need a S3 bucket for my service. They goes to SRE. SRE basically runs some automation, mostly Terraform, to create the S3 bucket or RDS instance. And then they get the details, pass it back to the developer. Developer is then using it in their service. That is fine, and it's like a straightforward process. Developer comes again with a new request now, saying, I also need a RDS instance now. Okay. The same process again gets followed where SRE or DevOps team provisions a new RDS bucket for their service, provide the details like endpoints, and maybe like how to use the credentials and all to the developer, and then they are using it for their services. Now, this is fine. This is a good approach, and for a starting point, it is very much okay. But there are a lot of challenges with this approach. First is scalability. It is not scalable, right? So if you have tens of developers, and then they are working on multiple environments, and then we are working in a distributed environment where you are creating microservices. So there are now tens of microservices, tens of developers, and lot of other cloud resources. For each and everything, you have managed cloud resources which you want to use. This is not scalable, right? It is very much blocker for a developer. So it also creates a lot of dependency on SRE DevOps team, because they need to like spend their time on doing small these things, right, for different developers or different services. One of the thing is, which is kind of a resource wastage kind of thing, because SRE's bandwidth will be going in repetitive tasks. Even though they have the automation, they can simply run a pipeline, S3 buckets or RDS will be created. They can provide the details, but again, it's a repetitive task for them. And then application team, like developers are continuously coming to them only for these resources. Suppose they are doing some kind of POC, and in that case, if they they need to reach out to SRE for each and everything, it creates a kind of a time wastage, or just some time will be lost there, right? Along with that, one of the major challenges, it is going to slow down the overall development and release life cycle. So if suppose if a developer can do everything on their own, they can try out some new feature within 1 day or 2 days maybe. But because of these dependency on SRE DevOps, and if they are stuck somewhere else, it can take up to a week. So it can slow down the overall development life cycle. So what would be the solution for this? So solution is basically to allow your developers to do everything on their own. So develop, deploy, release, maintain, monitor, everything should be done by the developer. As a SRE or DevOps, our responsibility should be to create the platforms, create the automation, create the pipelines, or whatever help you can do your developers so that they can do everything on their own. So this is pretty much called as a developer self-service. So you are allowing your developers to self-serve themselves whatever they need. Either it's a deployment to Kubernetes cluster, deployment to EC2 machine, or if they need a new cloud resource, or maybe anything, maybe creating a new secrets in Vault, anything, everything should be given, access should be given to the developer. Right? It will remove or at least reduce the dependency on SRE DevOps and speed up our development lifecycle as well. Okay, so in a nutshell, your self-service would look like this, where developer needs a S3 bucket. They have some access to some kind of automation or some kind of platform. They triggers it, get the information, and then they uses it in their service, and then they can move ahead with the development. Right. Now there are multiple ways to enable self-service, right? Which we are not now, but like every time, right? Since maybe a decade back, also we are working on these kind of things. The terms are different, the ways are different, but still we were working on self-service things. Okay, but nowadays, if you see, there are three main ways which I feel. First is internal developer platforms. So there are a lot of open source developer platforms being created, which many people might be already using, where you can just deploy everything from that particular platform, right? And there are free, there are paid versions as well for all of them. Other thing is like you can use some automatic provisioning tool, say with a UI, right? If it's a UI, it is much easier. That is why we develop applications with like UIs. So for example, take an example of Jenkins. You can easily create a Jenkins pipeline, fill up some parameters, and just click on submit, it will run, and everything gets deployed or created. Other part is infrastructure as code, right? Nowadays, and Kalp already shared a lot of details, right? What is the importance of Git? And then we also want everything to be tracked in Git. We don't want to lose any information just sitting somewhere in the logs or config file somewhere in S3 bucket. We want everything in Git, not the sensitive information, but everything else should be in Git. And for that, I think most of us are already using Terraform or maybe some alternative to Terraform to provision all of our cloud resources, manage it via Terraform. So these are the 3 ways to enable self-service. But it's not straightforward to go ahead and enable self-service for developers. Right? There has to be some considerations before we enable self-service. First is enabling guardrails. So as an SRE or DevOps, I know like what all should be parameter to be passed, right? What are sensitive parameters? What can cause what impact on our cloud platforms or cloud clusters, right? But as a developer, that information might be missing. Okay, some might be aware, some might be not. There is no standard that we can enforce here, right? By just telling them or creating a document. So we need to make sure that guardrails are enabled so that it does not impact or it should not cause any security issues with our infrastructure. Other is proper authentication and authorization. There are distributed teams working on different projects, and we don't want to enable everyone to use all the resources in the cloud. Maybe for some you want to, suppose some team is working only in the storage part, you might want to give access to only storage, right? But there are data teams where they might not need a, IAM role access, or they might need more data related things. So we might want to restrict that part as well, and it can. Then next is the audit features. You also want to audit everything. One thing is like you will be sending the logs to your logging solution. That is one way, but other than that, you also want to make sure that auditing is always being done. It is always present. And last and most important, it should be easy to use. If it is difficult and complex, then again, you are creating a burden for your developers itself, right? Even though you created a new tool, now they need to understand that new tool also. And if it is very much complex, then there is no advantage. Okay, now GitOps, right? So the topic of this presentation is self-service with GitOps. So do you know what is GitOps? Like, what do you understand by GitOps? Anyone? I think most of us are already using GitOps in some or other ways, but it's not very much clear what is GitOps. So in general, if I say, basically you are doing something on Git, pushing a MR to Git, and then whatever has to be done on the background, that is already being done, right? You don't need to do anything else. For example, you could raise a MR and it gets merged in Git. After that, your application is already in an environment, whatever environment you want to deploy. If that all thing is happening just by merging the MR, you can consider it as GitOps. Right? In a nutshell, this is what GitOps does. Okay. But other than that, there are other things also, right? One of the advantages with Git is everything is now tracked in Git. That is one of the core principles also for us to track everything via Git itself. Now, why we are choosing with GitOps, right? There are internal developer platforms, there are UIs we can create. Then why we want to go ahead with GitOps, right? When you can create a resource using one click. Why you want to use Git in this case, right? So there are multiple reasons behind that. One is awareness of Git, right? So even as a developer, I also feel like it's better for me to write a code rather than go log into a UI, then again click on something, wait for the response, and then it is very easy to use. I'm not saying it's not easy, but as a developer, my preference is to do everything from my terminal. Okay, maybe for others it might be different. Other part is authentication or authorization is already built in your GitLab or GitHub, whatever you are using. You might be having access only to required projects, right? You cannot go ahead and have all the projects access. But if you create a new tool, in that case, I need to maybe build an authentication authorization layer, or that tool should be providing that out of the box. Then only I can use it. Other part is the peer reviews. So I think in the previous talk, it was very much clear that what is the importance of code reviews and why it is very, very important for any company. And last, we need to build a code-based infrastructure. Whatever we do has to be tracked via code only. There should not be any other way. So, okay, now let's take an example of a simple application deployment architecture for any normal application, right? And this, I am taking example on a Kubernetes cluster. Okay, you can consider it anything, it should be fine. So a developer basically works on application code. He writes some application. His application might be in any language that is being containerized and shipped to any environment or any cluster. There is a dependency now. Nowadays, everyone needs a cloud resource. For example, to store some file, S3 bucket, to have a database, some RDS. right? And maybe DynamoDB or whatever is there, they need a cloud resource because that is a dependency, right? You need a storage somewhere, at least minimum. Other than that, there are other things as well. So you might be using queues and other things. So that is also there. So for application code, it is like pretty much straightforward. In our case, that create a new container, create a new image that your CI will take care of getting the new image. Then you just update the, and then this application code can be easily deployed by Argo CD to your Kubernetes cluster. Okay, this is already a self-service portal via GitOps that is already being done. And Argo CD is working pretty much great with integrating with Kubernetes. So all the things are being happening perfectly fine. But the other part, the cloud resources part, right? So there is a, it's not straightforward. There are not much tools which can provide. There are a lot of tools, but not all of them support all the features. And also it differs company to company. Maybe someone wants to use some other tool, someone wants to use, develop something which is customized, somewhere it might be internal. Okay. So in this example, as of now, it is being provisioned by Terraform, as of in our example, right? So any cloud resource, if you want, we provision it by Terraform. We have the automations. Okay, we have the Terraform modules. We just write a new file. It gets created. Okay, now if you see the last slide, we are proceeding with Terraform, right? That is already an automation. That is already a tool built, and it is pretty much great for provisioning cloud resource. It supports like pretty much everything what you can do via UI or CLI. So, but there are still challenges for the developers to provision cloud resource using Terraform. So now each developer need to learn Terraform, at least the basics that how to use a module to create your own resource, right? Other part is they need to, and then other part is there is a difficulty in enabling a guardrails, right? Because you're writing a standard module, but developer can also write a resource directly in your Terraform code. It's not necessary that they will only use a module. They can write their own code as well if you enable that feature. And then there is time is everything, right? So their precious time will be going in writing some Terraform code as well to provision a cloud resource, even though it takes like say 15 minutes of time. But again, considering the overall time, right? You need to again merge it, right? You need to get the reviews and all done, and then it will take some time for each resource maybe. Okay. And if again if syntax errors are coming with Terraform, some issues are coming, then you have to deal with debugging that or reaching out to SRE again. Then there is a dependency again on the SRE DevOps team as well. What would be the better approach for this is create some standard templates for your cloud resources to be provisioned. Instead of writing Terraform code, developer can create the resource using some pipeline, and that pipeline will internally make use of these standard templates so that there is a limited parameters available to developers, and it will also ensure that the code is not breaking, Terraform is working as expected, resource is also getting created. So from the developer's point of view, what is important is they should get the cloud resource which they requested for. How it is being created, they are not much worried about, right? And then as a developer, as I already told, they also want to do it from the terminal mostly. They don't, if it is internally, it is pretty much easy, right? So you just create a file, push it to Git, and then rest will be taken care. So a simple YML JSON file, which is very easy to write, that would be a better and simple approach. So for this, our company is basically using an open source tool called as Kubevilla for helping us in creating this whole self-service automation via GitOps. So Kubevilla is CNCF incubation project. It has like multiple features. We are using only a small feature of it, but if you want to deploy your cloud platform, anything on the cloud platform, whether it's multi-cloud, whether it's on IoT device, all those things are already supported. Okay. So some key features are deployment as code. So whatever deployment you do, that will be done via code. So you will be writing a small code in Kubevilla in their syntax, and then that will be deployed to your cloud, right? So it is again goes with the GitOps as well. It has like built-in security, compliance. If you want to enable something, if you want to enable workflows for your code, that can be enabled. Multi-cloud and hybrid support it is already having. Last is it is lightweight, and as well as it is very much customizable. So suppose you want to write your own wrapper on top of it. You want to write a particular script at some stage and make use of Kubevilla. That also you can do. Okay, and it's not that it is kind of depending on some language. It is up to you. You can also write your own schema files for creating a particular kind of resource. Okay. So to learn more, basically you can go through the documentation of Kubevilla. It has like lot of features. So we cannot cover all those things. This is the simple architecture diagram for Kubevilla, I would say, like how where Kubevilla exactly fits in. So on the left side, you see there are CI pipelines, right? You might be using Jenkins, GitLab, or any other CI pipeline, CI tool. At the end, you need resources on either on Kubernetes cluster that it needs to be deployed on Kubernetes cluster. It needs to be deployed on AWS cloud or any other cloud, or maybe some other on-prem cloud or on-prem servers also. So where it comes is Kubevilla basically takes whatever your CI is giving them, suppose a YML file, it renders it accordingly understand what exactly I need to create for where, and then after that it tries to deploy as per the configuration provided. These all things are handled by Kubevilla. Now you can again customize things, right? You can customize how you want to orchestrate it, how you want to deploy it, how before deploying you want to make some changes or not. Other than that, it also has a lot of add-on support. So if you see like it is already having support for Terraform as well. If you don't want to write like complete Terraform code, you can just you can even deploy directly Terraform code via Kubevilla itself. It also provides CLI, it also provides UI. So depending on the requirements, you can explore this tool as well to do it. We are just using a small piece of Kubevilla where we are customizing few things, making use of Kubevilla. Now this is one of the examples, right? This is how it looks a YML file, okay, in the Kubevilla template that will provision your RDS and S3 bucket. This is a line of code which will provision your S3 and cloud, sorry, S3 and RDS. So this is the API version, right? So Kubevilla has developed their own open application model. Okay, accordingly you need to understand the little schema of that, which is again customizable. If you want to have your own things in that, you create it. But at the end, they create a kind of application using the OM model. And this is currently deployed on Kubernetes. It can also deploy on as a standalone, but we have Kubernetes cluster, so we have deployed it on Kubernetes cluster. And if you see the components, this is the important part where the important part is the type. As of now, we are saying type is AWS cloud. This is completely as per our use case. So they don't enforce what type you want to. You can create your own type, and for that you need to just create a small configuration file called as Q file CUE. That is the file configuration which they are using, and in that you can provide, right? So if you see the properties, what all properties can be passed to this particular type that you can provide, that you can update in your Q file as it is. So in this, we have defined, say, a few important parts. The service name should be mandatory, environment should be mandatory, account should be mandatory. There are other optional parameters which we can create. So suppose you also enable tags, right? Or if you also enable which teams are you going to use that. Those things also you can update. This is complete. The schema file you need to update accordingly, whatever you want. And then other properties, cloud resources. In this property, we are defining what all cloud resources we want to create in AWS. Because this is a type of AWS cloud resource which we are creating. So we have provided, say, RDS MySQL, and then we are telling them that what is the instance class, engine type, and engine version. Similarly for RDS also, we have provided like the bucket, right? Then there will be versioning, and okay, another parameter has to be there. So you can also you also need to provide a name to your RDS bucket that is missing here. Okay. So basically, if you don't give a bucket name also, there is a default. So behind the scenes, Terraform templates will be there, which will take care. So if you don't provide a name also, it can automatically create a name, but it is recommended to give a name here. But this is not a mandatory parameter; it is optional. Now let's go ahead and understand the pipeline. So how a cloud resource provisioning self-service GitOps pipeline look like from the developer's point of view, right? So from the developer's point of view, developers triggers a pipeline, okay? So they create a resource.yml file, and this is the file looks like something like this, which we saw in the last slide, right? And then they create some merge request, which goes to GitLab. Then GitLab triggers, then there are GitLab events already configured, which triggers the Kubevilla application in the background on the Kubernetes cluster. which creates an application component. So if you see this, it's a kind of application, right? And there are certain components. So for this component, another pod will be created for that application component. What this pod does basically, it renders the components. Whatever, suppose you have provided 5 resources to be created, right? It needs to create some, it needs to render those, right? Whatever parameters have been passed, whether these are correct parameters or not, whether these are correct format or not, some syntax checkings, all those things it will be done at this layer. And then it creates another custom pod. Okay, this is the customization which we have done in our use case. Okay, what we are doing, we have already created some standard Terraform templates for all these resources. And then this pod is basically now rendering whatever you have passed, right? So suppose you have passed the database engine, database version, and bucket name. All these will be passed to this bucket. Sorry, is this pod, and then this will be that your Terraform templates will be rendered, and final Terraform files will be created, which is now your last step to create your resources. And then Terraform apply will run, which will provision your resources on the cloud. Okay. So till this, it is automated, but we also wanted to track this in Git. Right? That was one of the important part. We don't want to like give you a resource, but we don't know how it was created and where is the state file residing. Suppose we want to make some changes, or if it gets deleted, how do we reconcile it? So anyway, this can also be done via Kubela directly. Kubela can internally manage these things, but we want it to be in our Git. Okay. So what we are doing, there is another, after that, there is one more pipeline which simply whatever Terraform files at the end got created, that we are pushing to our repo also. Okay. So, and then it will be tracked in the Git also. We can go ahead and check what all created, who created it. So in this pipeline, we are getting a lot of advantage, right? So it is on Git, it is easy for developers to use. It is again the final output, final Terraform files are being tracked in Git. So we can easily go ahead. We can know who made what changes at what time from Git itself. So rather than implementing a completely new tool, we had used a small Kubela feature to do the developer self-service in our company, right? So this is the final pipeline. It looks like this, simple. Okay, I think that's it from my side. Any questions now, or wherever you feel doubts or anything, please go ahead and ask. Yeah, please. Sorry?
As the SRE of the company, do you control what a single developer can do in their resource.yaml? Like what permissions do they have? What kind of resources or components can they create?
So that we don't do, right? That is at the backend side, at the Terraform template. So we control, like suppose you want to create a resource for RDS, right? So in that case, what you can do is you need to provide some parameters, right? But that we control what parameters you can provide. So suppose I don't want you to create an engine like, create an instance which is like very much larger and specific for a dev environment. Why do you need such a big RDS instance? That we control from there. And then there are, and that we can also control those things, like if you want to control particular resources also, that also we can control. But as of this moment, we have not enabled that layer till now.
Got it. So basically, it will fail at the second last step. Like Terraform will basically fail it, right? If the developer asks in the resource YAML adds things that are not allowed, then
no,
it will
no,
kind
no.
of fail on the
It
second
will
last.
not fail at that layer. Terraform files are being created there. But if you see this layer, right, that pod layer, right, where Kubela creates that components, right, it also provides authentication and policies also, which we want to implement. If you enable those policies there, so you can control that particular thing at this layer. So it will not even create these pods, right? So the final KTS manifest also, which will be created to run your another pod, which is internally running Terraform, that will not even be created because it's a syntax error somewhere, right? It's an authorization issue basically. Okay.
Thanks for a nice presentation. I wanted to ask, like, at some point in time, when you are doing so much infrastructure as a code self-provisioning, then there comes a point where there is a lot of code review, peer fatigue appears. So in this model, do you also use kind of policy as a agent, like where you can inculcate policy agent on the changes on the go, and then those changes can be actually taken care of by OPA kind of policy agent tool, and then that fatigue can be taken out of your system.
Not yet. We are not yet applying any OPA on these particular codes, but we can do that. It is possible. We can write some policies there, and then based on that, we can easily control what all things can be done. So obviously, it will make our pipeline much more, lightweight. It will be like having less responsibility to do in terms of policy.
With respect to the tools which you have used, right now GitOps is a GitLab tool, and GitHub has actions.
Yeah.
Terraform till date it was open source and free, but now with IBM acquisition, the future is that Terraform will get merged with Ansible or the software development tower. Yeah. So how do you, and you yourself have shown in your means architecture diagrams about Argo CD, which is a contradictory for Kubevilla, right? So how do you plan to have these tools more generic, or what is the pluggability or ease of movement of components in your design?
Okay, so in this, if you see, we are pretty much blocked only by Terraform, and maybe in future we might be getting blocked by Kubevilla, because again, Kubevilla is now open source. We don't know the future, right? But at the end, if you see, what we are controlling is Terraform templates, right? That can be converted to OpenTofu for now, if that is open source, right? And if that is not possible, then obviously we need to write our own code, right? There are like other, I forgot the name, but I think Pulumi is one of the tools which can also be used to write your code, and you can move away from Terraform. But at the end, the basic architecture, if you see, right, we are just depending on Terraform templates. Suppose if everything goes away, if they take out, right, as a DevOps SRE, with the help of some developers, we can write a easily in-house tool, right, to just render the Terraform templates, or like create our own API calls also to it. AWS, at the end, resource will be created at AWS, so you can use your own APIs also. AWS has CloudFormation, right? Maybe we'll move to CloudFormation then. So there can be multiple possibilities. It depends whenever, again, some open source tool goes to closed.
Samit, one question. How is the approval process done here? So in the case of a developer raising a request for an RDS and a couple of ports for application development, that is one question. Second is, how is the cost controlled here? Okay. Third question is, how is the life cycle managed here? Say a developer has spun up, say, a database and a couple of ports. How is the life cycle managed here? When would the termination happen?
Okay, so first question, right? That the deployment you asked, right? So, okay, sorry, can you repeat the first question?
Okay. How is the approval process done?
Yeah, sorry. So the approval process is basically when the resource.yml, right, when it reaches to this step GitLab, when the MR is being raised, at that time also there is a pipeline runs internally. Okay, that will provide you the complete Terraform output. At then Terraform code will be output will be given, that whether all the resources are being created properly or not. And on the basis of that, other developers can easily review the code. They can see whatever is expected that is being created or not. So based on that, they can approve.
You create a template already and provide it, or developers themselves would create a template?
Templates are created by SRE. Developer just needs to use those templates. So when you provide this resource, right, here if you see, so suppose these resources are being created, right, AWS RDS MySQL or AWS S3 bucket. For this, we have already created a particular template, and only few things are allowed there, right? So that will also cover the next question, which is the cost control, right? We want the cost to be in a particular range, and the cost will be, say, depending on your instance size. So we can control like what is the maximum instance size you can create for your application. If they want something to like go, they need more for their application, then they obviously need to SRE for help, where we need to help them like how it can be done. Because for that, basically we have different versions also, which is currently restricted for this, right? So you have different Terraform module version which they can use for the particular resource. So this is how we are controlling cost. And what was the last question, please?
Life cycle management of the resources.
So life cycle is basically this once this file get deleted from our code base, it automatically runs the Terraform destroy as well for those resources. So as of now, there is no automatic termination for the resources.
Okay, thank you.
You also have crossplane, which does something similar.
Sorry.
Sorry, you have to repeat the question.
No, so when you were looking at kubewell as a possible solution for a self-serve, were there any other considerations like a crossplane, which is something similar to this, wherein you can write your claims and you can actually define to what queue size you can define? It just runs on the same custom resource definition kind of a concept. You have XRDs there you can define. So any thought on that?
So when we decided to use kubewell at that time, it's been like 3 years back when we started on that part, and at that time this was much emerging project which we saw, and we felt like whatever we needed right at that time, that is provided here. So that's why we started use. But I have not actually used crossplane yet. I have not even explored crossplane. So I might go ahead and check it. What are the other features they are providing, and maybe we can migrate from kubewell to crossplane also, because it is only rendering few things. At the end, the base is again with us only, the Terraform templates. So it should not be much difficult. But again, if it provides a much better features, then only we'll be moving ahead.
Any more questions? Cool. We'll take that as a no. Thanks, Samit, for the presentation. With that, yeah, please proceed to lunch. Post lunch break, we still have two more presentations, and we'll be also distributing swags. So please be here. Thank you.
Here.
When all of our embers became ashes of grain, but I've been going hard again. heaven, just like my lucky number 7. You're my shooting star. We're running round in circles. Love feels so invincible. Feel you when there's no one around. Your beauty's so amazing. I will always hold you down. Your heart will be kept safe and sound. But I don't wanna love you when I'm faded. You're the picture perfect, you're on my mind. Painted. And I don't wanna lose what we've got tonight. Baby, 'cause your love's like a dynamite. I don't wanna love you when I'm faded. I can feel your heartbeat to save it. 'Cause your love's underrated. 'Cause your love's underrated. And I don't wanna lose what we've got tonight. Baby, 'cause your love's like a dynamite. I don't wanna love you when I'm faded. I can feel your heartbeat to save it. 'Cause your love's underrated. Deep in my heart, I know you're irreplaceable. Together, unstoppable. And I feel your frequency, feel your love around me. I'm drowning in my mind, don't wanna let you down. We're running round in circles. Love feels so invincible. Feel you when there's no one around. Your beauty's so amazing. I will always hold you down. Your heart will be kept safe and sound. But I don't wanna love you when I'm faded. You're the picture perfect, you're on my mind. Painted. And I don't wanna lose what we've got tonight. Baby, 'cause your love's like a dynamite. I don't wanna.
I love investment.
Yeah.
Decathlon, 60 plus sports, 6000 plus.
Invincible.
ಕಾರ್ಕಾರವಾದ ಸ್ಪೆಷಲ್.
ಅಯ್ಯೋ ಬೆಂಕಿ! ರಿಪೀಟ್.
ಕಾರ್ಕಾರ ಈಟು.
7 up, repeat.
My Oppo F27 Pro Plus is machine washable. Get it pumped up.
I love Envato Elements because it is a one-stop shop for me as a
Welcome back, folks. We'll be starting in 10 minutes.
Now if I
So I'm also sharing APIs are sharing. Just take some time. We are doing. Yeah, I'll be sharing this. Already. Folks, we'll be starting in 5 minutes. If you want to grab a cup of tea or grab water, please grab it. Thank you. So our next speaker is Kannan and team. They will be talking about tracing, basically understand that how tracing will help us to debug and close our operations. So we will be starting in 5 minutes. Please take your seats. Kannan, I think everyone is back, so we can start. Folks, we are starting.
It's on. Am I audible? Yes, I am. Hey, folks. Thank you for attending on a Saturday night. Hope nobody's feeling sleepy. I think I myself had a lot of food. I'm feeling bloated and wish I had a nice black coffee. But yeah. Cool. In today's topic, we are going to talk about how to enable tracing for applications, and especially with OpenTelemetry. We will start with the introduction to observability, then what is tracing, and key components of traces. Then we will go with the demo. And for demo, we have 3 different types of instrumentation. How do you manually instrument application for tracing? Then automated instrumentation. Then a much better approach if the application is already running in Kubernetes. Okay, about us, I'm Kannan Anandakrishnan. I'm working as a principal reliability engineer at Arsatium. And with me, Atul Rautre. He's working as a software engineer at Arsatium. We both part of a SRE team at Arsatium. Yeah, first, let's talk about observability. I mean, we all work on observability in one way or another way. I mean, in recent times, especially after Google introducing SRE concepts and the SRE books, there are some of the things which we already do or haven't done have got a common terms, right? For example, golden signals. We already monitor what is the traffic, what is the error and everything. But now it all combined under a term, a proper standard as golden signals, where you monitor error rate, traffic, saturation, latency, etc. And likewise, service levels. For example, SLI, SLO, SLA. We all hear some in the IT industry, SLA is a very holy word, but now we have got SLI, SLO, and other kind of a structured, formatted one, right? So likewise, observability, it has been there for a while, and in fact, the definition is derived from a control system. It is how well internal states of a system can be inferred from knowledge of its external outputs, right? And they consider there are 3 pillars for it. Again, it's 3 or 4. Some people call it as a MLT, some people call it as MELT, so it's up to us to interpret, but we'll go with 3. It's metrics, which we all know. It's a numeric representation of data about the intervals of time. We all been capturing metrics, and even golden signal is a form of a metrics right now, right? And logs, events, it is a timestamp message emitted by services, applications. Yeah, which again, we all familiar with. We all, when we start coding, we start with print. Then people say, don't use print, 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 and use logging, and then we go to logging, right? Then finally, traces, which some people might be already experts over here. Some people find it new, and some people hear about it. Traces are, it's paths that follow requests through different system components. Like we hit google.com and it's just a request and we are getting a response, right? But there could be multiple components involved, systems involved, where the request goes through and finally we get a response, and tracing the entire thing is trace. And why do we need tracing? And given with all the microservices, I remember he mentioned he's a fan of monolith, but unfortunately now microservices are a trend. Everybody is going to microservices, right? There are so many components involved where you don't know the actual interaction of which component is interacting with which programming language they are talking to and everything, right? So even a typical example, if you take a checkout, which we do at Amazon or Flipkart, we do a checkout and we just wait for the next page to come. But behind the scenes, there could be so many interactions. There would be a card service which checks whether the items are available and availability for the PIN code. Again, that may not be a right example, but yeah, you get the point. It just does some operations. Then there would be a payment which goes for a payment gateway, validates your credit card, and just does all of those stuff. From a user's point of view, you click a checkout and go for it, and it just fails. It just throws a random error message. You don't know what's going on. So this is where trace comes into the picture, right? It breaks down request flows, making complex systems easier to understand. So you get to know flow of after the checkout action, where the request flows, which are the components it is interacting with. And it provides a complete lifecycle insight. And some developers here, you might have explored developer tools in Google. When you load a web page, you just go and see a waterfall model, how long it took for the page to load, right? Similarly, for the request, when it interacts with multiple components, where that time has been actually spent and which component is doing what job, it gives a complete visibility to it. So that is tracing, and there are key concepts involved in tracing, and one of them is span, which is a fundamental unit of a trace, which represents a single operation in a system. For example, even in the checkout, right? User clicks a checkout, then it goes for another service, right? That is a span. And span, again, as it says, it's a span of a time, how long the operation took time, right? That is what it is represented as span. If a single click makes calls to 5 different applications, and each one would be considered as a span. And each span would have their own metadata information, time-related information, when the span started, when it ended, how long the duration took, and along with it, other attributes part of the span. And trace is a collection of spans. And for each request, there would be a unique trace ID. Likewise, for spans also, there would be unique span ID. But the trace ID information would be propagated to all the spans via headers, which is called trace context propagation. And these all visualized as a root of spans. And this is collection of spans is called a single trace. Yeah, now we got it. So whenever we make a request, there would be a trace, and there would be spans, and there would be child spans, and it's like a tree-like a structure. So that is about spans and traces. Now, OpenTelemetry. And this is an open source observability framework, and it is just a bunch of collection of tools, APIs, and SDK. Say, for example, if you're already using Datadog provides their own tracing. Instrumentation, the problem is you would be instrumenting your application with Datadog, and you would be able to send only to Datadog in the beginning. You can't switch it to another vendor. So you'd be essentially vendor locked. And even in Kubernetes, like CNI or CSI, like a container network interface, where they define some standard structure, where it's up to the people to implement adhering to the standards in the way they want, right? So likewise, OpenTelemetry, it's a standard framework where using OpenTelemetry, once you instrument your application, you'd be free to send your traces, export your telemetry data to any vendor of your choice. And yeah, OpenTelemetry, short form OTel. And using OpenTelemetry, you can instrument the application to collect, process, and export the telemetry data. And telemetry data refers to logs, metrics, and traces. All three are supported by OpenTelemetry. Here in the session, we are more interested in traces. And it provides supports for all the famous programming languages such as Java, Python, Go, JS, and all those stuff. And it allows you to switch between different backends without changing your instrumentation. So instrumentation, it is sorted. And where you are sending the traces, visualizing it, and completely that is different, completely decoupled. So this is a rough diagram. The app you can, with SDK or APIs, you can instrument your application, you can export, send the metrics, send the telemetry data to a OpenTelemetry collector, and from there you can export it to any telemetry backend. And there is one important component in OpenTelemetry called hotel collector. It is an agent in the OpenTelemetry ecosystem. So it helps you to aggregate all the telemetry data, and you can do sampling over it. You can enrich your spans and traces. You can do sampling, and you can also drop certain error codes. For example, you don't want to capture all the spans which are succeeding in 200, which are working as expected, right? You want to capture only certain spans which took a longer time. So you can set those conditions and everything by receiving the telemetry data in your OpenTelemetry collector, and you can add those rules and other categories. So here in this example, you can see it is receiving data from OTLP protocol, then Yager and Prometheus, which acts as a receiver. And it can also do processing. Here it shows batch processing. And you can also do attribute processing and other kinds of processing over there. So after you did the processing, you can again export it to any backend you want. So yeah, that is about OpenTelemetry collector. Now I'm handing over to Atul to talk about instrumentation and how to instrument your applications. Yeah.
Yeah, hi. So yeah, so Kanan just spoke about OpenTelemetry and he spoke about tracing and why we need tracing. So now we're just going to look at how we can instrument our applications to enable them to emit traces, basically. So we're going to discuss 3 ways of enabling tracing for an application. One will be manual instrumentation. The second will be automatic instrumentation. And the third will be instrumenting applications that work as Kubernetes workloads. So the first one is manual instrumentation. First, I will just explain the demo environment that we have going on. So we have a simple Flask server that is acting as a weather app. It has a couple of dependencies. One is Vault, where it stores the API key for the weather API that we're going to hit. And the second dependency is SQLite server that has a table that it's going to query and work with. So let me just run the app. Yeah, so this is the app. And here you can just enter a city, and it will give you the weather data for that city. So this is what we're working with. And now we are going to go through the 3 steps of instrumenting the application. So the first thing is manual instrumentation. So as the name suggests, with manual instrumentation, we are going in and actually manually creating traces within the application code. So you need to go into your application and actually modify your application code and create traces to create spans that, again, combine together to form traces. So the first step is to import the required modules from the OpenTelemetry package, which include the exporter and also the other modules which help you add the attributes and other metadata to your traces. So it could be your service name, and it could be other metadata that is relevant to your process. So the first thing we're doing is giving the application a service name. The second thing we're doing is setting up the exporter. Here we're using OTLP as the format to export our traces. And this is the endpoint we're exporting our traces to. And then we initialize a tracer object, which is of type tracer. And then we use this tracer object to initialize spans within our code. So this is the first example. Here we start a span with the name HTTP and the method that we're going to use to call this API, which is going to be a post method when we fill the form in our app. Within this same function, we have another span that is created as a child span of the initial span. And this span will be called the fetch weather data span. And this will have additional attributes that we add manually called the weather.city and the weather.temperature and description. Can we just run the app? So as you can see, we have to create these spans manually, and we also have to add these metadata attributes in the code manually. So we're running the same app again with the instrumented code. And now we're going to see the trace in Jaeger, which is an open source tracing backend. Yes. So this is a complete trace of what we just did. So the first step, the first span here is a HTTP post call with our form data. The second was a fetch API key, which we manually instrumented within the app. The third step is the fetch weather data span, where we hit the weather API that we are calling to get the weather data. Within that, we have another child span, which is the update search, where we manually instrumented our DB utils, where the SQLite DB is getting updated. Can we show that?
Yeah,
So,
the error ones.
Yeah, here we just entered invalid entry of a city called Cow, which obviously does not exist. And we can see that that error is visible here with the error tag as true. So one thing with the traces is that we can visualize the time taken for each span in a request flow. So say, yes, exactly. So wherever we want to create a trace, we would initialize a span in that location. At the beginning, wherever you want. So the flexibility that we get with manual instrumentation is that you can create spans at any location you want to capture your business logic. That's the flexibility. Exactly, yes. So here we're trying to simulate a delay in the DB query. So if you get reports from your user base that say that, okay, this API is really slow. So now you could look at your metrics, but these metrics would be system scoped. And then, okay, it shows that this API is slow, but you need to find out where exactly in the request flow has the slowness occurred. So here we are simulating a slowness in the DB query. And then we can clearly see that this update search call is the call that has taken the longest time in this trace. Yeah, so with manual instrumentation, yeah, that's the thing. There are some downfalls. There is this additional overhead that developers need to add instrumentation within their code. And also they need to understand these packages and how to add additional metadata attributes. We saw that there were only a couple of basic attributes that we added, but that is up to the developer to be done. So in automatic instrumentation, some of these things are solved. So with the automatic instrumentation, we have the exact same app, completely vanilla, without any sort of OpenTelemetry packages added. And the only addition that we have to do is just show the only steps that we need to follow is get a couple of dependencies from OpenTelemetry and run the OpenTelemetry bootstrap command, which looks at the libraries installed in your virtual environment and then gets the packages, instrumentation packages that are required to instrument the libraries that you have in your application. So since our application is a Flask server, it is going to understand that it needs to get specific Flask instrumentation and then use that Flask instrumentation to instrument the app by itself. So it uses many different ways to do this. One of the ways is injecting bytecode during runtime. And as you can see in the trace, without any sort of code change, we are able to get traces for the application now.
Second.
Yeah, this is the latest trace. Yeah, and just show the tab. Yeah, so you can see that the Flask application, the Flask instrumentation here is now capturing so many more relevant metadata tags. So you have your user agent, the type of format being used to export the spans, the host that it hit the request to, the type of HTTP method. So all of this was not captured when we did our manual instrumentation. it could be captured, but it would be additional overhead for the developer to add. So since this is a standard popular library that is being used, and OpenTelemetry already has this instrumentation available, using automatic instrumentation is a really easy way to create these traces. And as it says, automatic, there is zero code changes involved. And the third, I would say the most interesting one is using the OpenTelemetry operator for Kubernetes. Since we know a lot of companies are now hosting their services on Kubernetes, using the OpenTelemetry operator is probably the easiest way to instrument applications and enable tracing. So the operator is basically uses the Kubernetes operator pattern, where the operator is basically like a controller which manages a certain set of CRDs. The OpenTelemetry operator specifically manages two types of CRDs. One is the OpenTelemetry collector, which Kanan spoke about. It can deploy and manage these collectors. And the second one is the instrumentation type of CRD. That's the one we're interested in, and that's what enables instrumenting applications that are running on Kubernetes. So in this demo, so there are a couple of dependencies before you can start with the operator. The first thing is cert manager. Because the operator uses mutating and validating webhooks, you need something to manage the certificates for these webhooks. So that's the first thing you install. And then you can, from the GitHub page, you have the operator Kubernetes OpenTelemetry operator manifest. And when we install those, it installs the CRDs, which is the instrumentation and collector CRDs. You have your service accounts and RBAC rules. And you have the and the mutating and validating webhooks. Yeah. So this is an example manifest of the instrumentation CRD. Here we have specified the environment variable specific to Python. So over here, the operator also supports most of the popular programming languages, which is Python, Java, .NET. Over here, you can specify all the different parameters that you would manually have to do in your automatic or manual instrumentation, like where you want to send traces, which kind of instrumentation you want to use. Do you want to export metrics and logs or all of those things? All of that can be done centrally through this instrumentation object. So here, specifically for Python, we have enabled tracing. And the mutating webhooks that the operator uses actually looks for a specific annotation that you need to add to your deployment file, based on which it will enable tracing or not. So for the deployment. Yeah, so this is the annotation, which is OpenTelemetry instrumentation inject Python. You just set this as true, and the operator is looking for this annotation, and as soon as it sees a pod with this annotation, it is going to modify the actual pod YAML to add an init container, which will then instrument the application itself. So the way it does it is by creating a shared volume between the init container and the actual main container application itself. And that's where it stores all the instrumentation. We have just deployed the application.
Annotation commented.
This is without the annotation, and you can see it only has the single container. You can uncomment the annotation. Yeah, so here, just show the init containers. Yeah, so as you can see, an init container was created, which adds all the required instrumentation packages for Python. and it does so in a shared volume with the main container. Scroll down to the environment variables. And in the main container, you can also see all the environment variables that were added by the instrumentation. So it also tells the main container where to send your traces. So yeah, that is with the Kubernetes operator for OpenTelemetry. I'm going to create a trace to show that I have a response. Yeah, and as you can see, similar to the automatic instrumentation, we have a trace available in Yegun. Trace with another. Yeah, so those were the 3 ways we can instrument the application. So back to Kanan now.
Yeah. And just to add, the automatic instrumentation which we did, where we installed the packages and we ran the command here, right? So this is the command we added. So even you can follow the same automatic instrumentation when you deploy your application in Kubernetes without using operator, where in your Docker image itself, you install those packages, OpenTelemetry distro and exporter OTLP, and you can pass these variables in your application deployment environment variables, right? You pass what is the traces exporter, what would be the service name, and OTLP endpoint, and everything. So some of the pitfalls over here is this. Say 10 application teams are there and everybody's using it, right? And this currently it is not versioned. Say for example Java, you would be downloading a Java agent and you will put it in a path and specify Java tools option where to pick the path and everything, right? So the managing the versions would be kind of difficult, and every time you want to upgrade the agent, you have to go and update your Docker file, and any changes you want to go and have to go and make and change over here. So there won't be any centralization available. And these are manual steps involved, right? And if you want to disable this, if you want to disable the tracing, again, you have to remove your environmental variables and everything, right? So yeah, the same approach. Mm-hmm. Yeah, so there is a technique called monkey patching. So some of the seasoned developers can explain about monkey patching, which I understood is during the runtime, it will dynamically inject, it will automatically identify where the function starts. It just wraps it up the code with whatever we have added in the manual instrumentation, right? We started with spanners and everything, where it depends upon the package and the library it uses. The OpenTelemetry automatically decides this is where I'm going to add, and this is where I'm going to end it, right? So that's why in automatic instrumentation, if you initialize a delay, this time sleep.2, it won't be visible here, which span exactly took 2 seconds. This database call, it won't show us it took 2 seconds, because the automatic instrumentation automatically decides this is where the execution happens, this DB execution happens, how much of a response it took. That's all it cares about. Whereas when you define by yourself on a manual instrumentation, it will say that, okay, the operation started from here, it took this much of seconds, and it would be able to give you this information. And this you can clearly see it in this over here. In manual instrumentation, this specific call took 3 seconds, where it actually representing over here. But if you go to automatic instrumentation, see, it completely skips the part. This particular operation took 2 seconds. It just says start time. Here the start time is 24 ms. Here the start time is 2 seconds. So where the 2 seconds went, which we added the delay manually, that won't be captured. That is the main difference. Yeah. Yeah, please.
So correct me if I'm wrong. Let's say OpenTelemetry frameworks like Jaeger or something, right? Normally, the way you said, if you are using automatic mode of it. It injects something into the header. So as per my understanding, you are only able to track the end-to-end service path where you have number of callouts across HTTP APIs, right? But the moment you hit a non-HTTP protocol, let's say a JMS, I'm not too sure if the automatic thing will work or not, because then comes the point where you have got a manual option in place so that if your service path is hopping over from HTTP to JMS and back to HTTP, you have to then use manual interjections or interceptions to be able to trace the end-to-end service path.
Yeah, yeah, you're right. So it does support messaging queues. It all depends. It's language dependent, library dependent. Messaging queues are supported like JMS. Messaging systems like JMS are supported. Even gRPC is supported by OpenTelemetry instrumentation libraries. But yeah, there are places, say for example, you are using some managed service and you don't have the ability to pass your header over there. Right. So those are places where you can enable manual instrumentation and add this context by yourself.
Correct. Just one last clarification. Can we use a combination of manual and automatic together and see them in a combined dashboard?
Yeah, you can. You totally can. Because you have the option of adding these modules by yourself, creating spans by yourself. And all you need is to start an exporter within your code and send these. And it does not interfere the actual automatic instrumentation in any way. So you have the option of doing both at the same time. Yeah, that's something we have seen. Yeah.
So is it possible that for some function, I want the automated span shouldn't go, only the span that I'm manually defining here, that goes, or if I can like alter what is getting injected at runtime?
Yeah, so there is even a sort of middle ground that you can do between automatic and manual. So for example, while we were working on this demo, we had the option of only getting the Flask instrumentation for even though we are using other dependencies like SQLite, which we saw in the automatic instrumentation where it created these SQLite spans and even the vault call was seen. But we could only get the instrumentations that we want. Say,
But these are more across the app kind of things, right? I'm saying that I'm happy with the overall
individual.
Yeah, for a particular function, I don't want the instrumentation that the automatic thing is injecting. I want here I have certain things, maybe some variables I want to add or subtract from the span.
When you do a manual instrumentation, that is for sure will appear. Only will it appear, automation won't appear. That again, even I don't know.
I will have to deal with duplicates.
Yes,
That's it.
Yeah,
that you can
because
figure it out.
automatic might create and you might create a span at the same time. So
but it's recommended is like combining the best of both worlds. It's what usually suggested, because automated ones, as you see, it's a huge learning curve, and this is something developers have to maintain. They have to code the code bases, and it would get complex, right? So for beginners and everything, it's automatic. Just what is out of the box, you are getting it. And if you are finding something is lacking over there, which is not something helping, then of course you can go and specific functions, you can just go and add it there. Yeah. And also, another thing I wanted to highlight is the difference, another specific difference, right? For example, this is error, okay. Yeah, so here, when it gets an error, it will just throw an error, and it will say that error is true, HTTP status code is 404. But other than this, it doesn't provide you any much information. Whereas with manual instrumentation, you can add more errors, more granular information, like for example, in manual error, here I added true, whether is error and what is the error messages I have got, so everything. So with manual instrumentation, you have more flexibility in adding it. And also one point to add is, I talked about OpenTelemetry collector, but here if you see, I'm not using OpenTelemetry collector for my demo. What I'm doing is, I'm directly exporting it to Yager directly and seeing it. So where the OpenTelemetry collector comes in the middle is where I could have exported the telemetry data to OpenTelemetry collector and enrich it there. It's like acting as an intermediary where you can aggregate your data, add more attributes over here, and you can do those kind of stuff. Yeah.
Sorry, when you mentioned this, I kind of got this. So is it possible that the span ID can be extracted in the manual part when there is an automated? So suppose the automatic instrumentation is on, and I want to specifically select the span ID of the current function and then add information to that.
Yeah, that is possible. So there are cases where maybe your application is written in a language that is not supported by the instrumentation libraries. Over there, you can manually extract the context headers from the HTTP call and then propagate that by yourself. Yeah, so that is possible. Trace ID, span ID, all of it.
And another advantage over this Kubernetes operator is, like we as SRE, initially we suggested every application team to do automatic instrumentation. And again, we just provided the document. These are the steps to follow. You have to add this jar agent in your Docker file, and you have to use this environmental variables and everything. And it caused a drift. Some application teams are using certain version. Some application team always catch up with the latest version. So even OpenTelemetry, when they introduced breaking changes from one major version to another major version, some of the attributes were breaking. For example, this HTTP URL is here. In the newer version, it would be URL path. So whatever we are doing sampling and extracting the values, that was getting, that was broken. So with Kubernetes operator instrumentation, where we have a full control over what is the agent version the application teams to use and what are the environmental variables they have to use, those we have full control over it. So that is one main advantage over automatic instrumentation, where application teams, they only have to add that particular annotation, and we decide what environmental variables to be added, what version of agents to be installed in them, etc. And some of the production best practices, and of course, if anyone have questions, feel free to ask. So these are our lessons learned, right? And our learnings, which we see as best practices, right? So initially itself, you can decide your hotel collector deployment strategy, like what kind of strategy we want. Like for example, we are asking all the application team to directly send their traces to our collector, which is running as a deployment. Then we do sampling and everything. Then we are exporting it to Yager. So here, what you can do is, there are multiple options available. You can run it as a collector, as a sidecar to your application itself, or you can run it as a daemon set itself. Those kind of options are available, right? So earlier you decide what approach you want to go. That would be helpful. And sampling strategies, like I mentioned, right now we didn't apply any sampling strategy. So all the individual calls being made or captured. This is just demo up, but if you have an application which are receiving so much of traffic and making all the calls, you would be bombarded with so much of spans. So we can set what kind of sampling I want. I want to capture all the 50%. I want to capture only 10% for the high volume. For the low volume but critical, I want to capture all the spans, all are important. And you can, like I mentioned, you can also choose whenever error code is this, I want to capture all the spans. Whenever error code is 200, I'm okay with 50%. You can also choose, for example, I don't want to see any spans with HTML render or Jinja render. I can completely drop it. That options and all, you can do it in a hotel collector. Then observability backend. Sorry?
That is, sampling strategy works only at the collector level, right?
Yes.
That means each and everything will be traced by the code. It's only when it goes to the collector that it gets dropped. So
yes.
It's a decision of whether you keep it in the database or not.
Yes.
But the data is getting collected.
Yes, that's true.
So my question is what is the sort of overhead you would have seen between running the code with the collection and traces on versus without any sort of instrumentation? How much overhead does the tracing mechanism add to the entire app? Because that, I think, is the bigger concern rather than disk is cheap.
So over in the sense, the application teams so far haven't mentioned that it causes an overhead for them, right? Whereas when we collect all the stores, our collector mechanism, we have a load balancer, which will then, it gets bombarded. And our storage also just shoots up like
That is
everything.
right. What I meant to say was, so you showed us Python code, right? That I was just thinking that if I would be doing something like C or something, I would have done a if hash def tracing on, and then I would have compiled the code with tracing, and I would have basically seen some sort of a difference. I mean, all sorts of collection mechanisms. So I was just wondering whether there's any documented area where how much performance hits are there because of tracing.
Yeah, so I mean, obviously we have also done similar testing because application teams won't just enable tracing without them understanding and being sure that, okay, this will not, cause them to break their SLOs or whatever. So especially with Java applications, which is the majority of our apps, we have seen very little overhead, almost none.
So we usually measure the application startup time, given that we are running in Kubernetes, whether instrumenting it causing any additional delay in their startup or anything of that sort, whether any resource shoot up or anything, but it's kind of negligible. It doesn't impact any of their
CPU profiling, the memory usage of, we're using batching processor to send spans, how big is that queue getting? All of that can be managed as well. You can really go to the nitty-gritty and check that out. So, and it also really depends on the application. So even we tried to look up online before we enabled all of this, what is the kind of overhead that other people see in their applications. But I mean, the majority of the information that we got was that it's completely dependent on the libraries that you're instrumenting in your application. So it's something that you need to test and find out by yourself.
Question, right? I mean, I may be wrong, but in my previous experience, when we tried Jaeger implementation in automatic mode, it led to an overhead of almost 1.5 to 2%. Yeah, I may be wrong up and down, but roughly in that range is what we saw that time. I'm not sure about how much we have observed.
Did you use a Jaeger for instrumentation itself? Because Jaeger also has their own library to instrument it, right? Jaeger
automatic instrumentation.
OpenTelemetry automatic instrumentation, sending it to Jaeger, or Jaeger automatic instrumentation?
Directly Jaeger.
Directly Jaeger. Yeah, that also varies from providers to provider, vendors to vendor. That is vendor specific. Yeah.
And this was on Java. Basically, as I understand, it's playing with your stack trace, right? Your method stack trace. So there is one overhead there. Then one obviously sending out the data to the central data store. So, yeah.
So the next one, this is one thing we found it interesting and important one, capturing custom headers, right? Even if you're using automatic instrumentation or manual instrumentation, right? Every organization would have their own unique ID for all the application team would have already installed. For example, AWS, I think AWS X-ray ID or something. So the applications being built in an organization, they would agree to what is the request ID to show internally. If you have already adopted a common request ID method format or something, you can also add it in your application via environmental variables so that whenever somebody accesses a application page and gets the error code, they would get a request ID. This is the request ID, right? So you can directly take the request ID and go and add it here. So depends upon, again, this depends upon the observability backend. But you can see Jaeger has HTTP status code as a tag filter, error equal to true filter. So if it is one of the attributes, you can just come and add it. For example, this one has, that is manual, right? Okay, so I'm just entering error equal to true. And it will just list all the error traces, right? Likewise, the unique request ID also, you would be able to come and provide it and filter it accordingly. And finally, managing agent versions. That's we already covered, yeah. And any other questions? Yeah, thank you, folks. Thank you for this entertaining session, making it quite interactive. And thank you, everyone, for asking this question. Yeah, this you can contact us in LinkedIn. And yeah, thank you.
Thank you, Kanan. So the next we have from Chen Duty. So the last session, please be awake. Don't feel sleep. If you're feeling sleepy, please gravity.
Yeah. Get me a sip of water before that. Oh. Okay. That's fine. Yeah. Okay. Yeah.
Just click on this.
Hello? It's on, right?
Yeah, it's on. Yeah, we can hear you.
Okay. Okay. Yeah. Thank you. Hi guys, Shyam here. So today the title of the talk is like getting most out of the logs at the 3 a.m. So basically like when you need the logs or when you troubleshooting or debugging the production issue, then how logs can help you and how logs can be your companion while the crunch situation. That is the topic that is the topic of the talk. Yeah, sure. Let's get started. Who am I? So just give me a second. Yep. So as you know, I'm Sham. I work as a software engineer as a Zen duty. You can connect with me on LinkedIn. I'll share it afterwards. Yeah. Uh, yeah. So as I like already talked what this talk about. So like during this talk, I'll explain what and why we need a logging. What are the common logging scenarios generally like logs or for a debugging or some other purposes, and what are the logging best practices should like every organization follow from like which we have learned in the hard way, and how to use the logs at the 3 a.m. So what is logging? So first, in the simple words, logging is like the
capturing or gathering the events generated by application on the production or like any operations. So like it's basically like it's telling what's going on, what are the what event has occurred, what event it's failed or success, or something like telling what has happened during the cycle. So why is logging? So basically, logging is required for like you are facing some issue. Let's say particular functionality is not working as expected. It's failing. You is throwing 500, or like its service is down, or maybe like monitoring the performance of the particular endpoint, or it's which is a very critical. You need to follow some certain latency, like certain time limitation. It should be respond within a 2 to 3 seconds or less than that. So that for you can monitor the health and all these things. So yeah. So one of these troubleshooting the prod issue. It's like we have like as you know, like Zenduty is the incident management platform and the on-call management platform. Reliability is utmost priority for us. It's reliability is utmost priority for all the organization, but for its for us it's a more reliable because our reliability, it's like others reliability concern depends on our reliability. So we cannot go down for like for a minute as well, because they like the client who's trusting us, they can go wrong for them. So yeah, so for us, so mostly the issue or the customer query we get is like incident is not created. So like let's say they have integrated Grafana with Zenduty. So Grafana is sending the alerts. Zenduty is not creating the incidents. What are the flow of the like a request has passed from the Zenduty, from entering to Zenduty, running the few checks and then creating the incident. So for that we need the logs. The other common request or complaint we got is like I'm not getting a proper notification method. Like I'm not getting a call when there is an incident. I'm not getting a SMS if there is an incident. So for those issues, we need a logging to check what are all the operations is has done, what are the events, what are the function is passed through, and then what are the checks and which checks failed, so that that particular on-call engineer like didn't get a phone call or SMS, something like that. Yeah. So then monitoring the application, like if there is a endpoint, you optimized it. Then you need like what was the metrics before, what is the metrics after for a particular endpoint, what is the P99, what is the P75, like that. So for that also, and one of the most useful for it's a security auditing. So as we have the like we are the SaaS product, we need the auditing logs for our client to verify what all the operations has been done by their employees, by their use. So like it shouldn't be like some user has came and deleted the integration. So now they are not getting the alert for that particular pod or that particular service. So that we need to make sure like that auditing logs we have, so that we, if someone came and say like I'm not getting the alert for particular integration, particular service, so we can go and say them like yeah, because this particular user has deleted this, so it's from it's their like responsibilities from their side, that they manage the access like that this doesn't happen afterwards. So like security auditing and all that. So like many of customers would like ask us is share us the audit logs, what are the other users have done on Zenduty, how many incidents are created, how many times they try to log in, if someone is doing the multiple time with the incorrect password, then block them or all these things. So for that also logging can be helpful. Yeah, so then basic, it's a very basic, like what are the things, components are in the logging. So it's a logger, handler, filter, and formatter. So logger is the entry point which captures the event. Handlers is responsible to deliver to the destination. Whether it's a file handler, it will write to the file. If it is a stream handler, it will write to the streams and like that. And filter is kind of useful, where you can filter out the particular events. Whether it's the info, then you need particular things. Whether it's a error log, then you can add more data, more contextual data on the particular event, logging event. There's all things, it comes handy on the filters and formatters. It's to format all the event data, all the contextual data in the particular format, let's say in JSON format. So formatter, it's convert all the unstructured data to a particular JSON structured data. So this pictorial representation of like once the program runs, it logs the message, logger comes up with the particular configuration information, like what are the configuration the logger is, then a file render which writes to the file, then filter format, and at the end it writes to the log file. Yeah. And what are the common logging scenarios is like basically for a debugging issue, you write like log1.debugger, but this is a debugging message. Like this event has completed successfully like that. So you can get a trace at what all the function or what all the operations has been done, and error handling where you expect some error by calling a particular function or particular code block. Then you can put it in the try catch, and at the at the error you can add log the error message and with the other stack trace or other contextual info. The other thing is performance pointer, which I talked about. You can use like logging for a basic performance monitoring, where you write the start time and run the code block, and at the end time and log about like particular operation took this particular seconds or something like that. And then the security auditing is particular exam is performed. You can emit the logs like particular user specific user log or perform particular action. So this can be useful to safeguard applications. And so like as you know, like as a startup, the more focus it should be shape the feature fast. They don't rely mostly on like modular code or logging, or for startup it's most they focus is like we need to shape this feature fast. So for them it's like without logs, when there is a production issue, there might be some issue or they can't debug what has happened wrong in there. So it's just a try and error. They guess there might be issue with this particular block. They push a fix. Then again they ask client to do it again, try it again. If that doesn't solve, they fix again and again. So that can be a very tedious process, or that can impact like the reputation of the company and how reliable they are. So that's all like. We also face similar, not similar kind of issue, but at the very end start, Zenduty, we had very basic logging, so like applications like API invoked, API ended with error or success. Like it's very minimal logging, so we couldn't figure out the things. So then we go then we start focusing on the logging better. How can we how can we make it a bit better? So one of the major mistake is like ignoring the context with the log message. So as in the example, it's like I'll just they made a API request and they blanketly accept the exception, like whatever the exception. This exception could be a timeout error or any HTTP connection error or any error. So then it just said like a request failed. So there is no proper context saying that why request failed, what are the stack traces, what are the trace ID, who is the user who's making the request, whether it's the user engine, whether it's the like from the HTTP handler or from the say browser or like that. So this can be like while debugging, this kind of has useless log, because you don't know what is the reason of the failing of the particular code block and how you can debug. So this happens in a hurry where developer who's writing the code or who's dealing with the particular code block, he's like it's a basic issue, like it's a request fail error. Anyone can get the idea what went wrong and what. So, but while debugging, when some other on-call engineer is debugging his code, when there is an actual production issue, then he can't get the context like why it went wrong. So this is one of the major issue. Then not setting a proper log level. So let's say like you generally like in a hurry or without proper context, you make all the log level as a info or error or something like that. Or you label the log message as a like incorrect, whether it's supposed to be error, but you logged him as a info or as a warning. So this particular type of thing can badly affect the application. This has happened to us as well, where one of the billing services, they like particular when we update the quantity to the our billing provider, uh, there was an exception if quantity if the particular like number of sheets doesn't update in the our billing provider, so then it throws the error. But the developer who's writing a code is just accepted the error and make it as an info log that saying that there is some issue with the sheet quantity updation from the billing provider side. So, but that could badly affect the company's revenue or something like that, because we, as quickly as we, like if we didn't notice this in like a long term, then it could be badly affect our revenue or badly affect the like financial of the company. So here like if a proper error like log error is, we would have set like, let's say if it's a critical code block, if the error logger error it's like error, then it would have thrown the incident and would have we got in our attention that this code block is like getting failed multiple times in a single like a short span of time. So there may be something wrong with the our code block, or maybe something wrong with their billing service provider, so we can contact them and sort out the issue as soon as possible. Yeah. So then is unstructured data. So like while logging like while logging the particular message, you like message you type the message, and with this message you get the context, you give the context of the data. So like if you don't have the like central thing, and you like maintain the like, let's say here in the example status object, you define the status objects each and every part, then there might be issue with like you in some part you mention some contextual data, in the other part you mention some other contextual data, so it's not, or you miss some like important contextual data. So there might be some issue with that, and then when you debug, you can't get all the contextual data, and you might miss the some message, because let's say like in the previous talk they mentioned about the trace ID and all this thing. Via trace ID you can trace all the events which has happened during the request life cycle. In that, if in the single place you miss the trace ID, that event won't gonna show when you search with the trace ID in the logs. So in that case, you might miss that particular entire event, and you thought like, and this particular request cycle is never touched that part of code, and you that can be issued. And yeah, structure of the data, and and this particular issue we also faced. So let's say like you provide the proper contextual data, but at the like in one place particular key has a value of type integer, and the other where the particular key or like a value it's a string or some other data, let's say in the JSON format or in the dictionary format, and the other is just a string or any other type of data. So while in the visualization, let's say for Kibana or Elasticsearch, where you visualize these particular events and logs, that platform might reject, saying that there is a mismatch of the event type. So there, in that particular time, you might, because while loading the data from file to there, there might mismatch, like they might reject the particular record, because saying that the data is not, like data type is mismatched. So in particular case, let's say in this example, the operation was just successfully completed, where the line number is integer 15. In the below one, where the line number is 15, but in the quotes, in the string. So while pushing this data to the visualizers or let's say Elasticsearch or Kibana, the second record might have missed because there is a type mismatch. So you don't get the whole idea like operation, why particular thing failed, because in the logs you have logs still like operation 1 successfully fell, in the second operation it failed. So this is for us also this like for us there was a one key where we are sending the integer ID, and then the other place we were sending the key ID as a string. So we also faced this particular issue where like we were debugging. We thought this particular code block never hit because we didn't get the like log message that this particular request is failed, that particular code block. So then we realized, then we checked the logs of the Kibana or Elasticsearch where we are pushing the data, and then in that logs we got to know that this particular record entirely is rejected by the OpenSearch. So yeah, so like we listed down all what are the common mistakes, and so what to keep in mind when we writing the logging. So as like previous talks has also mentioned, like include all the necessary metadata, like what are the user agent, what is the user's name, username, like user's email ID, IP address, and all the other contextual data like line number, what's the function name, what's the line number where code exactly failed, and all these things. But that doesn't mean like you mention all the details, like what is the request body, what are the all these things. Like that can be unnecessary data, or there may be too much of data where like in the critical moment you kind of lost in particular like all the data. So in like logging all these things, you might log the like sensitive data. It's like PII data where it mentions like you have a password or other financial data and like credit card number and all these things. So you like must keep in mind like what data needs to be logged, what not needs to be logged, and log level should be the proper, like whenever you need info log, it should be info log. What are the events or like particular messages for debugging, it's not for other thing, then you can log it with the debug error logger, and you can pass it uh, you can get it in the other stream and other file. That's like in the coming information I'll be talking on that. And one of the thing is correlating key. Try to like as we have the like multiple things like Kubernetes matrix is also following one of the logs, application logs and other logs. So try to add or some similarity key. So or you can correlate the logs. Let's say there is a spiking particular matrix on the Kubernetes side. Let's say like memory spike or CPU spike and all these things. So at particular time, if you have the data, if you have the trace ID and what all the requests come in that particular span, and then you can get from the trace ID you can get what all the function it is executed in the application, and from there you can get to know the what are the operations which are the CPU intensive, which are the memory intensive, and then based on that correlation of the log, you can get the more idea of the like what's the exact issue. And as I mentioned, keep the log structure. Yeah.
This thing that you mentioned about correlation, right?
Yeah.
So OpenTelemetry does that automatically, right?
Yeah.
But is it possible to use your own homegrown solutions to do that? Because I'm thinking then you have to send requests, embed that correlation key within that and do it. So does it even make sense? I'm just trying to say, because lots of people want to roll their own solutions without really and not wanting to use what's available.
Yeah, so like what we have tried to do in regarding this, we have our own homegrown solution. Like we don't use OpenTelemetry, and we use the basic Python libraries for these things. So what we do, like whenever the request comes to our application, the first when we call the logger, it sets all the necessary parameters. Like in this log structure, let's say status object, we embed this particular status object at that in the entry level itself, where we not exactly, but like what's the trace ID of that particular thing what are the username, users, username in the ID, their email ID and all these things, IP address and all things. And then we send that particular request to the, goes through the application. And whenever we perform particular option, we need its, this contextual data can be needed in the further. We add that particular contextual data in the status object. So let's say like each and every step we add extra data in the status object, like what has happened, and like that. And whenever there is a log, whether there is a operation failed, we log the particular message like this particular operation failed with the status object. So from the status object we get to know like how is the path of the log, what all the operation has been performed and from where it's gone through. So we can get to know, like let's say line number n function, it will be set at the time of writing a particular log. So we write that what's a function name and all these things. So we add that in the subject status object and we publish the log. So basically when we search for a particular trace ID from the request, we fetch all the details, like what are the function it has said, what the message and all these things. Yeah. Yeah, and then once you have the better structured logging, you can better visualize the events. Let's say for one of our example, whenever the incident or alerts been created in the Zen duty, we publish an event like alert created successfully, incident created successfully. When we publish the particular logs, it's for it's general info logs. It's not that being used, but it's being used at a particular time where we can manage the graph. We can better visualize how many incidents are getting created each and every minute, 5 minutes, 10 minutes, hour, and all. For there we can we can get to know what's the average traffic, if there is a sudden spike, and what's these metrics can be useful by not only the tech team, can be useful by business teams and other various growth team as well. They can get to know about this particular metrics, how many users are being added in the last 1 days or 2 days or last week, how many teams are getting users are how many companies are adding more users, or vice versa, if particular client is deleting the members and all these things, then they can reach out to them. It's is there anything wrong, is there anything wrong with us that you are removing the users and all these things. So this particular better visualization can be these particular events can be used in the visualization, or as we said, precise alerting. You can mention let's say we publish a message alert creation failed. So where then we can write the particular threshold, say let's say in last 20-30 minutes, if particular event has occurred multiple times, let's say five times, 10 times, then we can create the alarming, and we can create the notify the on-call engineer this particular events are, there are multiple occurrence of particular events which is getting failed. So you can look into that particular thing. Then yeah, it's improves the better response time. If once you have the event structured, once you have the visualization created done, then once the issue comes where it's you can directly correlate with the metrics graph and the events graph. You can most common scenarios you can get to know from by looking the visualization itself. You don't need the taking to the application logs, searching for a request ID and all these things. So you it will create it will better your response time. As we mentioned, it improves the team collaboration. That this particular graph can be used by other teams. Reduce the alert fatigue, where you can customize your threshold. You can let's say my threshold was, if the particular event failed in last 10 minutes, I'm getting too much of alert, and that's the kind of false alarm. It's alert fatigue that you can, and if it's not that critical, you can expand the threshold to let's say 10 to 15. If 15 alerts, if 15 events which is failed, then give me the alerts. So alert fatigue can be reduced and all this. Yeah. So yeah, and one of while logging this one like which we have learned the hard way is like you get to know when to log. So like uh, with the proper messaging. Yeah. So in the example, I'm like in the request, I'm like carefully catching the like timeout error first and writing the relevant message with the timeout error with the particular status object data. And if not a timeout error, I am catching the connection error and then writing the particular message like cannot reach the Slack server or cannot reach the some other particular server. So here you can get the exact what's going wrong in the particular code block, or let's say uh, here the example is, let's say in the try except I accept the blanket exception like accept exception, and then I try to log the request got failed. Then it's hard to debug like what went wrong that request didn't like request fail. So if we and one of like one of the scenario we have the code block, we put it in a try case, and we the developer didn't know that what all exception can be arise while executing the logs. So there he just blanketly uh, accept all the exception and write the basic logs and done. But that particular query, it's like kind of important where we are doing some we are going through like if we whether need to be called or SMS, whether is passing all the checks or not. So in that particular time, there was a issue with the database connection. It's not able to make the connection with the database, or there was issue with the table. I can't remember, not getting, but there was issue from our side. But it was passing the exception, and the code was continuing from there. And the customer was complaining like we are not getting the SMS, we are not getting the phone calls and all these things. So there then I proper debugging when we checked all the logs, and then we get to know that it was a blanket exception. So it wasn't the creating a particular error, and it's not alerting the on-call engineer that a particular block is failing due to particular thing, particular reason. So where so then we learned in the hard way like don't log the blanket exception, let it fail, let it application fail. So it like what are like whether all the let's say in application we various application performance monitoring tool like Sentry and other can catch that particular, and we get to know where what's the particular issue, so we can get and fix that, and we check and what are the next then we can think about like what are the next exception could be happen in that particular block, and we accept that also. And the log storage, so as I mentioned, logging of too much of information can cause the at the end you need to store the logs, so it adversely affect the cost and thing. Then you can so there are various logs, let's say Kubernetes ingress logs, application logs, and if you other microservice, then all the microservice logs. So it's recommended to put it all the in the centralized where you can get all the logs in the particular application or particular window. So you can search from the correlation ID and each of the logs, and you get to know all these things, like rather than switching the sites on switching the windows and all these things, and improves the indexing. So you are like what are all the most used keywords or most used keywords to search the particular log. Let's say you are searching more on the message side or trace ID side or any other correlation ID which you are using, then make index that particular key or value key, so it will be easy to search and implement the regular backups. And one of in the log storage, how much you retain the log in the particular say let's say in the hot storage, you retain last 30 days of log. Then you move to the cold storage. What's your archiving policies? How in how many after how many days you are archiving the particular logs? Let's say then these are the uh, things to be uh, because it's like it's related to cost, so it's you need to make a balance how much logs you want and how the cost you can bear. So that's the trade-off you need to do. And alerting, as I mentioned, like once you have the better logs, you can set the alert based on the frequency. Try to uh, first try if you are not expecting the particular log event, then you can make the bare minimum threshold, let's say 2 to 3 events particular span of time. Then like once you get to know this is the like frequently occurring event, then you can increase the frequency or threshold, sorry, include threshold and all these things based on like. So once you have the proper logging and events and all these things, you can in the sometime you'll get to see the event patterns or patterns. So how the logs are getting generated, what's the event and when it's occurring, on what's the pattern. So based on the pattern, you can set up the anomaly detection as well. So let's say like if there is a massive spike in the particular event, then the application, like whatever the applications you are using, can alert you based on the anomaly detection. So yeah. And now like once you have all the things set up correctly, like with the proper log level and all these things, you are like once you have the critical issue at the particular like crunch situation, like who's on like who are in the like on call engineers and in the SRE, they know how frustrating it is to wake up at 3 a.m. and debug the particular issue. So in the particular theme and the thing, on logs are only your companion. You can rely only on logs because that are the only source of truth you know, that what has happened in there. So like once you have the visualization, you can get to know like why this particular graph has spiked and what are the like, let's say I have the timestamp and the count of particular event type. Then what are the last let's say in the green line it's a past uh, but success rate and what is the failure rate. If I'm low placing a like creating a visualization there, then I get to know that it's throwing more 404 or like a 400 request and all these things. Then I can check what's wrong with the application and those, why is the anomaly. And then if there are a specific condition where like you are not expecting the error, it's out of your error boundary, or you need to debug a specific request. So one example I can take is like customer asks us that like I'm not getting a phone call, I'm not getting the SMS for a particular incident, I didn't get the particular phone call. So then we check what's the what's the trace ID related to that particular incident, who created the particular incident, and we check all the logs, what has happened. Did it created the incident successfully? After creating an incident, did it created the subsequent task, what needs to be created? And then in the subsequent tasks, we have few checks whether it's eligible for getting a phone call or a SMS like that. And then we place the phone call or SMS notification, whatever. So in that particular time, we need a request ID, we need a correlation ID, where from the ingress we get the correlation ID, and then we search it in the application log. And the other we use Celery as a task job where the scheduler perform a task with the scheduled time. So we get to know that what all happened in the task, or whether the task has executed successfully, or what the error throws in the task, and all those things. So that trace ID or the correlation ID can be handy. You don't get lost to the all the logs, all the application log in at that particular time, though it's a limited time. Let's say you want to see the logs for a particular 1 or 2 minutes. So based on your traffic, that there might be hundreds of entry or thousands of entry in a particular span of time. So request ID or correlation ID can be helpful to trace the exact issue. So this is one of the example of the how trace ID can be useful. So here, like this is the example where like we verify the phone number to get the notification, to get the phone call. So once we have like we log like API invoke, then subsequent what all the event happens, like whether needs to be verified that particular phone number or not, whether the phone number is valid or not. Then we like basic sanity checks, and then checks the pricing and all these things. Need to verify price or not. So all the events we have subsequently written, and then if all these things pass, we send the verification code. So this is one of the example how we can get and take the like trace ID and get all the events and don't get lost to the log. So there are multiple practice generally organization follows, where they have the parallel streams running, one with the normal info, error and warning logs, and one with the debugging logs. So then their particular streams are running, and they write both in the parallel stream, like one is writing in the single file, running in the another file. And mostly in the bigger organization, developer has the like info level logs access, like info error level logs access. So if a developer can't get to know from there, then they give the access to the debug level like logs, and then to write the like to get the exact pinpoint of error, and then help the writing the RCA. So this is also can be implemented, so you don't get lost in the logs, like there are too many logs in the single file at the single window. So you can separate out the debug logs, separate out the logs at per their log level, or you can separate out the logs based on their module. Let's say based on their particular module, like authentication module, other module. So like that you can, and yeah. And like what are the common logging practices that follow using the open source? There are many tools which like you can, let's say like a OpenTelemetry, or if you want to use, you can use it like a New Relic, New Relic Datadog and all. They provide the logging things and their own with their own like expertise and customization. But these are the common like open source which you can like you can maintain by your own. Let's say like ELK, Elasticsearch, Logstation, Kibana, where like a Logstash is the extract the logs from the like files, or wherever you are writing the like in the streams, and push it in the Elasticsearch. And then on top of Kibana uses as a visualizer, where you can visualize or create the graph, create the like all the histogram and all these things, and you can search particular things at the Kibana level. Same EFK, their only difference is instead of Logstash, we are using Fluentd as a log aggregator, and the last is Grafana, a log key. So basic diagram of the EFK is like this. And so application server, it's collect the data, Fluentd collect from D as a collector, collect the data, then Fluentd fetches the data, aggregate and ship it to the Elasticsearch, and on the on top of Elasticsearch, we run the Kibana dashboard to visualize the data better. Same in the Grafana, log key is like POMTEL is the log collector here. So POMTEL ships the data, log key centralize storage, store the data centralizedly, and on top of you can using the Grafana to visualize. You can use the alert manager to create the alerts and send to the right on-call engineer. Yeah. So that's all for the best logging practice and how logs can be useful at a crunch situation. Yeah. If any question.
Thank you, Shyam. Thanks for presentation. Any questions?
Hello.
I have a question on this log-based alerting, right?
Yeah.
So would like to know your individual perspective and also Zenduty's perspective, like what is the best practice? Because again, it varies from organization to organization. It depends upon the
Yeah.
approach. Some people say that log-based alerting is not a very good practice because if a particular log occurs, error message occurs, you are creating alert, right? It should have been captured in the core application logic itself and emitted as a metrics, then you capture it because then you would have a better alerting. You would know whether the metric still remains the same. Is it an alerting condition?
Yeah.
Whereas in logging, there is no normal state. The disappearance of particular error message is considered as a non-log, right? If the same error message keep on occurring again and again, it would be creating multiple alerts. Or if you say duplication of alerts, you added a check.
Correct.
Then you would never know that when the particular alert state has been resolved, right? So I would like to know your thoughts on that. Yeah.
So as we mentioned here, like get to know like what are the logging scenario you want. So as I mentioned, like don't catch the error blanketly. Like if you are expecting some particular error which is a warning level, like it's a warning. You don't get if particular things. It's not that high priority. It's maybe like let's say it's happening like once in a while or like 2 to 3 times a particular hour or particular time span. Then it might be issue with some other issue. Let's say here in the request thing connection error, there might be issue with this Slack, not these applications Zenduty. Then this might be a warning error for me. So what you can do, you can take the pushes this log as a warning level and then write the alerting, say, let's say like if particular events comes like the burst of this particular event, then might be an issue with my team. Then it's a might word is there. So you like you cannot concretely say it's the my issue or the receiving application issue and all this thing. Then you need to debug. So this you need to like this fine tune you need to do like with it will be done with the time period. Let's say like you are getting the issue, you kept the threshold as a 5 in last particular like let's say hour. It's occurring multiple time. Then and you check it's a false alarm or it's not that high priority. Then you update the threshold to 10, so you get the last alert. And then if still it's generating like you are getting this particular log message again and again and again, then mind you can suppress this particular log message. You can remove and all these things. And but if you are not expecting a particular exception in the particular block, like we suggest, don't log it, let it fail, let the application monitoring tool alerts you. Then you'll get the better idea like why it's failing with this stack trace and trace ID. So then you can fix that particular log. Otherwise, that particular message will get lost in the all the like similar logs. And like if it is really important, then if you know it's the error with your application, this might be, let's say, some database issue or some integrity issue at the database level, then accept that particular error, create the error level. So then you can, if particular event occurred, you can set the alerting. Like if a single particular event occurred in the logs, you can notify the on-call engineer. So it's it will evolve with the time. You can like update the threshold with the time. So it's based on your need, how application wants and all those things.
Yeah. Thank you.
Yeah.
Any more questions? We'll take that as a no. Thanks everyone for joining.
Thank you.
With that, I would like to call Ankit for a closing note. Ankit is head of engineering for Graph in Core. He has recently joined, but yeah, he is well aware about the Graph policies and weights.
Thanks, Anil. Hi guys. So yeah, I'll not take a lot of time. I know a lot of us have already left and we must be waiting to just move on. Yeah, but quick thoughts. So Anil asked me to literally take maybe 2-3 minutes. So one thing is, I mean, obviously I want to thank everybody. Personally, it was my first son only. So it was my first event also, and I really loved the topics that were covered. So we start from security, then we covered code review session. I like the product ID, and I would like to, talk to you more about that. Then the whole thing around observability, OpenTelemetry. And then logging, a very good session. So overall, a good sequence of sessions, I would say. Anshu in the morning, whoever was there in the morning, he covered AI, right, to a slight extent. See, we do talk about AI a lot, but from my experience point of view, whatever we discussed today, that forms the basic of AI, I would say, right? You start from here, you first try to implement your basic infrastructure, then you automate, and then you bring in the intelligence or artificial intelligence on top of it, right? So I think whatever we covered was good today. However, going forward, I would request, and including me, including Grab, right? I would request all of us to cover some AI-specific sessions also. By the way, Grab is trying to become an AI-first organization, by the way. So there are a lot of initiatives, not only at SRE level, but also at entire Grab-wide level, which we are initiating to embrace AI in everything that we do. And when I say everything, I literally mean everything, not only engineering, even on the field, on our drivers, merchants, everybody, right? So there's a huge wave of initiatives which we are now planning to run over the next 2-3 months around AI. And the objective is to become an AI-first organization. And obviously, because Grab is hosting this event, Grab is investing a lot in India, especially in Bangalore as a tech center. So we'll be happy to talk to anybody who would like to work along with us. That goes without saying. So thank you everybody. But yeah, one more thing, last thing is, I hope this session was useful to everybody. At least I have a couple of takeaways from this, and I would discuss that with you and with you, right? And so please try to, use all of this in your day-to-day work. I hope all of us learn together, collaborate, and grow together. Thank you, guys. Thanks, Anil.
Thanks, Ankit, and thanks everyone to join today's LSP. Along with Grab core vertical, Grab also has the DigiBank vertical. So we have 3 multiple banks in 3 countries. This we are also expanding. As Ankit already mentioned that we are expanding in India, the same way DigiBanks are also expanding in India. Feel free to reach out to the team here, be it me, be it my team, be it Ankit, anyone across to check out if you're interested to work with us. We have a lot of interesting open role. We want to work with interesting people. Again, AI being one of the most talk of the town. With that, thanks everyone. Thanks again for joining. So we will be ending the presentations as well as the recording. The floor is open for the discussions. You guys can have tea and can discuss with each other. In another 5 minutes, Dinil also has some announcement to make. So let me take it offline. He may be connecting with the people here to get some more details. Dinil, you can join. You can have the mic. Let me continue. Thank you.